Testing 1, 2, 3. If folks can hear me, please let me know in the chat. First couple minutes will just be making sure that this live stream is working, and then I will get rid of my headphones pending that there are no audio or video issues. You are kind of quiet for me. All right. Let me increase the gain. Is that better? I can also increase the gain on the mic as well. Still quiet, better? Let me know. Like I said, the first couple minutes we'll just sort out audio video issues. Much better. All right, if there are ever audio issues or video issues, let me know. I'm going to take my headphones off because I'm not going to be talking to you guys. You guys are just going to be leaving comments and questions in the chat. All right, so welcome to this live stream of demystifying the Jelly programming language. First things we're going to do, if you listen to, actually, so yeah, let's skip over to here. If you listen to ADSP, the podcast, aka Algorithms, Data Structures, and Programs, and you've listened for a while, you'll know that I was, at one point, a big bubbly fan. And I came across, oh, there's a bit of a lag, but I assume you can see this, a Mary Berry bubbly flavor. So this is a first ever trying of this flavor. That's not very good, but it's all right. We've got 12 of them. We are going to be fueling this live stream with this Mary Berry bubbly. And today what we're going to be doing is we are going to be taking a look at this programming language that was created by Dennis Mitchell a number of years ago. It was primarily inspired by the J language, and it has some interesting language features that I do not understand at this moment. So we are going to build a tool called Jello to demystify this and understand these language properties. If you don't know about my favorite languages, I can do a 60-second recap. All of my favorite languages are array languages. You can see 4 logos on the screen: APL, BQN, J, and Weewa. Weewa is the newest, BQN the second newest, APL the oldest, and J is the second oldest. Technically, I wonder if I might need to sign into Twitter. Actually, so let's go to the APL wiki. No, wrong wiki. And if we search, what is it called? APL family tree, I think it is. Yeah, there's this. So can we zoom on this? Yeah, so there's this very big, good diagram of all the different APLs and how they relate to each other. So I believe APL 360 is the oldest. And I wonder if this one has jelly in it. So there's J. It does not look like this one has jelly in it. But if we go back to these two diagrams, and we zoom in here, there's J and there's jelly. So it's this kind of esoteric language. There are links in the description. What's the goal? I'm not sure if you joined late, Joao, but the goal, I mean, we're gonna take a look at this jelly language. It has some interesting language properties that don't exist in any of the other array languages. However, it's a very hard, amongst the array languages, a hard language to understand. We'll get to that in a second. But the point is to basically understand and become jelly novices at the end of this and not have to type all of these symbols. So gonna pause. We'll come back to jelly. The point is here is that J inspired jelly. Jelly has actually gone on to inspire a ton of languages, some of which I've tried to look at, but these are all just kind of like pet languages, I think. I don't think any of these have any serious like users, although I don't really think Jelly does either, but Jelly has, I think, well-known enough. No, sorry. Oh, Goal is a language in the... Yes, Goal actually, I think we might have Goal on the ArrayCast. It is a K-inspired language. Let's Goal programming language array. Yeah, this seems right. I mean, it was on... Also, what... I don't understand. Why are people hosting on these alternative GitHub sites? It seems unnecessary. Yeah, so this is like an example of Goal code, I should say. So it's very K-inspired, or Q-inspired, if you will. I don't know much about it, though. But yes, it's just one of the newer array languages. Is my camera frozen? No. So yeah, Joao was just asking if I had heard of it. I have heard of it. I don't know much about it, but we might be... Oh, so I've mentioned ADSP, the podcast. So if you are a subscriber to this YouTube channel, if you're not, you should hit the subscribe button. But if you are and you want more content, I very consistently, for 156 weeks straight, have been releasing these episodes. So if you want more content, I know it comes in podcast format. We've been thinking about creating a YouTube channel for it, but it just seems like unnecessary work for like what marginal gain. However, I also have a second podcast called the ArrayCast, where we interview a bunch of different folks. Some of them are the implementers of array languages. Probably the most well-known people, Rob Pike we interviewed, who's the implementer of the Go programming language out of Google. And we also interviewed, who's the next most well-known? Probably Jeremy Howard of data.ai or fast.ai. Anyways, we might be interviewing the implementer of Goal in the future. However, today, so close this tab, go subscribe to all this stuff. What are we doing today? We're going to be taking a look at the Jelly language. What is the Jelly language? The Jelly language is a J-inspired language that if you go to, it's actually interesting, the GitHub, so the links to both the GitHub repo and this jellyballs.github.io are in the description. Interestingly, the GitHub repo doesn't link both of these links, maybe this one is supposed to be to the github.io site, but both of them link to the TIO, Try It Online, which is kind of irritating. But anyways, this is the fun site. And from what I understand, so this is, over the next few hours here, this might be a 4-hour stream or a 10-hour stream, depending on how quickly we get through this stuff. From what I understand is the major difference between APL-J and Jelly is that APL and J use digraphs and Unicode symbols that are ambivalent. So they have multiple meanings per symbol. So if we go, actually, let's go to BQM. Let's talk about this. BQM bad. This is something that I think is a big mistake. So let's talk about ambivalence for a second. What is a good? So a good use of ambivalence is the following. This is negation in this case. We are negating the number 5. However, this is let's do a little monadic, just because I'm going to be using terminology that everyone should be familiar with. These two words are interchangeable for the rest of this stream. And this refers to the arity of a function. So in array languages, typically, you only have unary functions and binary functions. There's also like niladic functions that don't take any arguments, but for the most part, we're gonna stick in this zone here. And so whenever you hear me say monadic, it has nothing to do with monads. It just means a function that takes one argument, and dyadic means a function that takes 2 arguments. Sometimes I will switch between saying monadic and unary and dyadic and binary. They're interchangeable. Just checking in on the count on the comments. Oh wow, haven't done any Jelly in a while because the Jelly author is also the TIO author. Yes, that is correct. Dennis Mitchell, the individual that created the Jelly language, also created the Try It Online, which, if you're not familiar, is a website where you can basically try a ton. Oh, I didn't know that. Dialog is a big sponsor. You can try like every single language under the sun. It's got a limited interface in terms of what you can do here, but if you are looking for a language, you can probably find it on this website, as you can see. Anyways, back to ambivalence. So, what is or technically, it's ambivalence is the way you should be pronouncing this. It means that functions are both monadic and dyadic. So in this case here, this is the monadic version of the subtraction glyph, meaning that in this case, this is negation. However, we can call it in the dyadic case, and in this case, it's subtraction. And this is probably like the best example of a function that you want to have both a monadic and dyadic definition. However, almost every single glyph in J, APL, and BQN has this ambivalence. And it can lead to, a lot of confusion when you're reading the code. And I think a lot of them are unnecessary. Like, for instance, multiplication is obviously, 2 times 3, multiply. That makes sense. But like, what is this in the monadic case? This is sine, which, okay, sure. Like, that's nice. I like having a sine function, but does it need to be overloaded? Does it need to be the monadic version of multiply? Not really. Which is, if we go over now to Weewa, wonder if that'll come up. Weewa, there we go. And we go to pad. We got to change this, though, because I need a different font. Weewa 386. So in Weewa, we can do the same thing, but here you've got one thing for negate, but we don't overload. So we've got 2 different symbols for negation and subtraction. And actually, subtraction, if you hit enter. I love this. This is a small thing that Kai Schmidt, the creator of this language, did, but whenever you run it, he automatically lines up the comments. I'm not sure if he did that because he saw one of my videos where I was manually doing that. Absolutely love that, though. But what you'll note here is that the color of the high minus for negation and the regular minus for subtraction are 2 different colors, because this, I believe, is a monadic function and this is a binary function. Or I guess actually this isn't negation. This actually forms a array literal. This forms the negation, because green means a monadic function, blue means a binary function. So interesting. Actually, so we should type that out. So what is negate 5? Yeah, so this is actually a literal minus 5. And the whole point here that I'm trying to make is that I think ambivalence is overall bad. So Weewa, of these languages, actually, do I still have my little, this. So of these languages here, APL, BQN, and J all have ambivalence, whereas Weewa does not. And Jelly also does not. And when you get rid of ambivalence, it enables you to do more things with point-free programming, tacit programming, etc., and combinators. Question from Audrius. Hello, I am new to array languages. Could you please suggest a good video introducing the field, jobs, etc.? Is there even a good video? I mean, let's just go to my channel and see. What's the best introduction to array language? Actually, I know which one it is. In fact, it might just be the video, because I'm not a subscriber. Where's the functional versus array languages? This video right here. Am I allowed to copy things into the chat? I mean, is this actually the best video? Maybe not. There's another one too. Where's the one where I compare this one? So actually the title of this one was a look at array languages, but I renamed it for YouTube because YouTube, actually, man, it's only got 24,000 views, so maybe it would have been better if I renamed it to something else. Both of these are great starting points. You know, if other people in the chat, if you've got suggestions, feel free to. Oh, that's delicious. Well, not really delicious, but I do like a carbonated beverage. Anyways, yes, if you've got questions, feel free to leave them in the chat. Back to my ramble on ambivalence. So APL, J, BQN all have ambivalent functions. If I can type. Weewa and Jelly do not. And I think that, put a little happy face next to this. A lot of the APL folks and array language folks will argue because of this negation and subtraction that, like, it's terrible if you have to have two different symbols for something that's so related and that this comes up all the time. I would argue it doesn't come up all the time. The main one that comes up is negation and subtraction. And, like, doing this does not break my heart or soul that I have to have two different symbols. It's pretty nice. And it gets rid of a lot of confusion in, like, being able to visually read code. Ben saying at least BQNs is context free. Yes, that's definitely true. I mean, APL, that's a whole side tangent that there are certain cases where not only is it ambivalent, but the interpreter can't even correctly parse what you mean. So you have to do some special stuff. And BQN, don't get me wrong, BQN is still my favorite language. I think Weewa is my second favorite language, but BQN is still my favorite language. So even though it has ambivalence, it doesn't ruin a language. I'm just trying to point out that this whole digression on, one, understanding monadic, dyadic, unary, binary, it's going to be important because I'm going to be saying those words all the time. And two, that you can see here that we have categories that are color-coded similar to Weewa, where we've got monad for monadic functions and dyad for dyadic functions. I actually don't know what the rest of this stuff means, and here are the niladic functions as well. We are going to figure this all out over the next few hours. But here's the first example. So if you hover, let's see how well we can hover over these symbols. I happen to know, it's very hard to make that out. I happen to know that R is the equivalent of iota or range. So if we go back to BQN here, this is our range function. It's called iota in APL, and it just gives you a range. BQN is 0 indexed. We can go to Weewa, and I guess it's going to keep on building this up. So let's do this. Actually, we can just comment this stuff out as we go. And I believe we can just type range here. And if we do this in Weewa, you're going to get 0, 1, 2, 3, 4. And in Jelly, it's R. So you can type R. And then if I actually don't know how to run this here. So we're in the main tab here. If you type your expression in here, your argument in here, so X is your first argument. So that's the number of arguments we want for a monadic function. I don't actually know how to run this. So to run this, you have to go to the next tab where it'll maintain the expression. You click run, and then you can scroll down and see that it gives you the output 1, 2, 3, 4, 5, which is pretty good. We've written our first Jelly expression. But there's a bunch of rules on, like, how this works in terms of, building up these tacit expressions and how, they form combinator patterns. We're going to get to all that. That's the background. That's what we're doing today. Blog de Luna says, does Jelly have some similarity to functional languages like Haskell? Probably. I don't know. Jelly. That's what we're doing today. We're figuring it out. And Stuart says, I looked at this page once and noped out. I mean, I did the same. But I mean, it's been on my list of things to basically go and figure out how this language works. So that's what we're doing today. And then Ven Dethiel, if I'm pronouncing that, says, we need to get rid of, there's a heart that is obstructing my view. J's separator category is in the same category as BQN's. So if we go back here, interesting. Okay, so there's a bunch of starts a new link, token separator, starts a separate nylatic chain, starts a separate monadic chain, equivalent of this prior thing. I guess I'm going to need to know how to, we're going to need to look up, I mean, that's a pretty big oversight. Or no, it has the name, separator. No, that's the category. So maybe a little word of advice to Dennis. It would have been nice if he, because I don't actually know the name of these diacritics. So like you can see that you've got R, then you've got R with a dot underneath it, R with a dot above it. We're going to need to figure out how to speak these, because at first, are we supposed to refer to them as the name inclusive range? So what is this one? Reverse Z. So let's try this. What happens if we... What? Okay, yeah. What happens if we do this now? So this, I would expect, reverses my iota sequence. What the heck? All right, the site's frozen. All right, we've crashed. How many people are watching? Only 30. I mean, I find it hard to believe that if every single one of you is at this website right now, we've crashed GitHub. Off to a good start. All right. My first jelly seg file. You know what? We don't even need this website. The plan is we're going to go and clone this. So here, let me... So we've got this now. Let's just go grab this. See if we can get this running locally. So git clone cd... while we... Ooh, I didn't do the Q. Not sure what that is. pip3 install. So yeah, let's just follow these instructions. All right, so apparently we're done. Hello world. Look at that. We ran our first jelly program. And so also too, I think this is like a pretty bad thing to do, because when I saw this, it initially turned me off. Like if we, how do we zoom in here? Like when I initially saw this, I thought like, what in God's name is going on here? But this is like you know, they've taken some actual Hello World program and then like encoded it into some inscrutable thing. So this is an actual jelly code that you would write. So now let's see what happens if can we actually run, I don't know, I assume that means Unicode something something. So if we paste this and then put, well, we'll figure that out in a sec. Oh, I see. So your expression, there you go. So you want your expression, your tacit expression that you're building up to be in single quotes, and then you want the argument that you're passing it. So now we can do this locally. Not what I expected. So remember, this was reverse, and this was iota or range. In the comments, dash Q is for quiet. All right, no worries. Wouldn't a hang in jelly be called a jam? And it's left to right. All right, look at that. We've got folks in the chat that seem to be familiar with this language. So let's get rid of this R. There we go. We've written our second jelly expression now. And so my guess is based on the fact that back on this page, there was a separator for the monadic chain, is that because we're just stringing together monadic functions, they just evaluate one after the other. And we can do that. Let's go find the, let's just hover over these for a bit. So T is the equivalent of replicate, or what's called replicate in BQN and keep in Weewa. So it returns you all this. So if you do, so we're just going to hop back between BQN, Weewa, and Jelly. So if you do a to mod here, oh, right, because we've got prefix functions, and now you do a keep. So it's going to give you the indices of all the elements that correspond to ones, which is going to be, oh, right, but then you have to duplicate. Huh? Do I have to swap as well? Right, we have to duplicate this one. And then we go keep. Which I think actually BQN, I like BQN's way better. You do mod, and then they just have, I believe that's replicate. So you don't need to do any duplicating of the initial list. So technically keep in Weewa is a dyadic function, replicate in BQN is a monadic function. And that's actually a pattern in Weewa. So like one of the things that I really like about BQN is BQN has a sort primitive. In fact, it's like the only array language that has sort primitives. And that's very important in my opinion. Weewa, what you have to do is you have to, if we just put, 3, 1, 2, you have to duplicate this, then you have to, what is it called, grade? Nope. I know what it looks like. It's the arrow. Where is it? This one right here. Rise. And then you do a select. So like, this is how you spell sort. And if you then use this, that's how you spell sort in Weewa. Whereas in BQN, it's just a single symbol. It's left to right. Why not do the tutorial? Sure, we'll do the tutorial. But first things first, we're just messing around. And what I want to do is very quickly get up and running a little script that is going to. We're basically we're going to get ChatGPT to write us a Python script that invokes the subprocess module to, do all this stuff for us, so that I don't need to type this. I can basically just type. At the command line, iota, I guess we're going to have to do it left to right. So iota reverse 5, and then it'll convert this behind the scenes to this. And because, I could set up my international keyboard and learn how to read these diacritics. Actually, so we've already got ChatGPT open. What do you call a diacritic where there is a period below the letter and above the letter? A sesame dot? The diacritic is used. Wait, yeah. Which one is below and above, though? A period below a letter indicates the first tone. What? That's not what I'm asking. All right, let's just go to Google. Pretty bad fail. That I mean, is there no way to, like, colloquially speak them? Let's go back to ChatGPT. Can you give me a table of the names of, and their names, please? All right, perfect. Except the one that they call it is dot above. I mean, that's a pretty... I guess we'll just call it dot above and dot below then. That's really irritating, though. And so what are the diacritics that are commonly used here? Is that it? It's basically just dot above and dot below? I mean, we got to figure out a better way to say that. I'm just going to make something up then. I might just say below and above, although those are 2-syllable words. Over dot and under dot? All right, Stuart with the answer. So when referring to these, we're going to call this R under dot, and this R over dot. And I guess actually those are the only ones. Except for, what is this? L? Looks like a inner dot. Yeah, we'll figure it out. In the font, the dots barely stand out. Yeah, I mean, I'm not a big fan. It's probably why I learned about this language months and months ago, and it's taken me so long to start digging into it. But all right, so now let's do a new one of these. And what do we want to ask? We want to ask, and we might turn this into like a little GUI application at a certain point. But for now, we're just going to do everything in the command line. So can you write me a Python program that uses a sub-process to pass a string to a executable called Jelly. But I mean, that's really all we need. And then prints the and let's say and turns the text red and prints it. Let's just see how far that gets us. Thank you very much. Oh, and also, actually, before we do this now, we need to... So we're going to call this program Jello. Hey... Python script for wrapping public. That's fine. Wait, that's the wrong one. Where's the SSH? All right. Touch. Jello.py. Let's come back to this. So actually, yeah, we needed to take not just a string, right? Actually, no, we can pass it this whole thing, and I think the way that you can do that is just by I can never remember. We might need to play around with this a bit, but for the moment, that's what we will. So yeah, I think if we do split there, well, actually, let's just go tell ChatGPT what we need. I forgot to mention the program is Jelly, but the command line args you pass to it are can you modify the program accordingly? Yeah, there we go. And then we can set that up ourselves. So let's well, and actually, I mean, we'll jelly. So yeah, let's kill this. And can I run jelly from here? Oh, look at that, I can. So I don't need, this might actually just work then. Python 3. What? Returned non-zero exit status 1. I got. Oh. Knows this. Isn't that wonderful? Just get rid of the decode. Cannot pop from an empty list. I mean, what if we try the following? Okay, so we definitely can't do that. What if we try... Like, I'm almost positive these all need to be separate. Chained up pop if chain else chains pop. Odds that ChatGPT knows how to fix this. I wonder if it's I mean, strings in Python 3 are UTF-8, so it should be fine. And I'm not actually even sure if you need UTF for this. Yeah, I mean, I think it does. Stuart's asking, does it need it in the double quotes? And I mean, if we go back to this, I imagine this is going... It doesn't actually. Oh, okay. Oh, there we go, folks. Thank you, Stuart. I am not sure at what point, because in the example here, he has it in single quotes in both of these, but clearly it's not actually necessary at this point. So now we can build, we can do the rest ourselves. Get rid of this, get rid of this. We don't really need all these comments, do we? I mean, we can to-do fix this. And now what I want is a little loop. What is this, a knit function? Oh, this is for Colorama. Change the name of this. Change the name of this. Print Jello. And then what we want is while true, input equals, actually it's just, what do we call this? Expr equals input And we're going to change this to two different things. We want expression, which is going to be a string, and then we want I mean, we'll change this if we need multiple arguments, but we'll stay in monadic land for now. And once we have this, we are going to arg is going to be x per -1. I mean, how actually do we want to do this? Yeah, no, that's true. And then, and we're going to need another function called, we're just going to call it convert. And it's going to be a expr, which is going to be, I don't actually know what the, you know what, we'll add this in a sec. Actually, it doesn't even matter, right? Because, you know, it's going to, and this is going to give us our string. And this is, how are we going to do this in a list comprehension? Return this is going to be a, we'll just call it token. And actually then we're going to join this. And it's going to be to jelly. You know, t for t in expr. And then we can call this, you know, converted expr equals, we'll come up with some better names for this stuff, but it's gonna end also, this is a bug. And we're going to do this to everything with the last one. And that should basically be it. And I don't need a comment that says run the function. So then we pass our converted expr with our argument. And then we come up here, replace this with our expr. Our arg, we should be good to go. And so now the only thing we need to do is we just need to continuously build this out. So if token equals r, or no, iota, we return r. And now we're going to need to go to the Jelly website to get our codes. All right, let's see how many mistakes I made. Let's go back here. I did mean true. Where is true? That's in the while loop. So start the mistake counter. That's the first mistake. All right, and actually let's clear this. So now if I type iota rev 5, I want it to convert, so what is this saying? Sequence item 0, expected string, none type found. So, print expr. Oh, and actually, we are going to rl wrap. Ooh, can I do that to a Python expression? So now if we go iota rev 5, okay. Oh, I didn't split it. Ha ha ha. Ooh, and actually, I didn't split any of this. What am I doing? So this, I guess we should strip it as well. So that's the second mistake. Haha, there we go. So I mean, I haven't really been explaining what I've been doing here, but hopefully it kind of makes sense now. We're gonna need to reset this colorama thing here. But I want to be able to type some like readable Q-ish language. And so it was only 2 mistakes. That's pretty good. I mean, there actually might be a couple of them. We're just haven't encountered them yet. So yeah, what is the, let's just go ask ChatGPT, even though I've used this. What is the colorama command for resetting color? Yeah, you just plus that to the end of your string. That should do it. And so we don't actually want to print out this. What we do want to print out is the converted expression, maybe? So print converted expression and let's come up with a cprint is S for string, C for color. I don't actually know what the type of 4.red is. And we just do a return. Well, it's actually just a print. Print. I guess it's, yeah, C plus S plus 4. Reset. So this becomes cprint output text. And we want it to print out this, and this is going to become cprint. So for this, we can go 4. I don't know, yellow? I don't know. And for that one, we'll just leave it as 4.red. All right, let's come back here now, kill this. Actually, let's put this at the top. So now when I do this, actually let's add some spacing in here. And add it in here as well. Right, so now basically I can write this. It's gonna convert everything except the last character in the monadic case to this expression, and then it'll just feed the whole thing to the Jelly interpreter and evaluate it. So I don't need to mess around with learning all these characters. I need to learn it once, put it in my little table, and then I can forget about it. Maybe cyan instead of red. Sure, we can change it. What is better? Maybe green. Also, is there a way we should bold this stuff? What is the style bright? Let's see what happens if we do that. Is that bold? That doesn't look bold to me. To make the text bold. Are you sure? Why are we experimenting with jelly? Because, I mean, we haven't got... Are we at the hour mark? Yeah, we're at the hour mark. Because once we get to the tutorial, which we're going to read through slowly, there is this idea of chains, which if my assumption about like how this works is correct, is going to be pretty amazing. Because I started off the stream talking about ambivalence, there is no ambivalence in Jelly or Weewa. And then because of this, Jelly has a whole, I don't know if you want to call it an algebra, but basically it takes advantage of the fact that because there's no ambivalence, in other words, the arity of all the functions are fixed, and so you can rely upon the pattern of the arity of the functions to enable composition patterns. And it's kind of similar to what Weewa does, but it's more just like a predefined, everything is prefix. When you encounter a binary function, it eats two things. A unary function, it eats one thing. Whereas I think there's more going on in the Jelly language. I could be wrong. We could, finish this stream in 5 hours and be like, oh, that wasn't that interesting. I don't think that's going to be the case, though. Arity is just the number of functions that a function takes. The number of arguments that a function takes, sorry. All right, I mean, let's commit this. We have, I don't have the queue here, so you got to Control C. Git status, git diff, cat, I guess. We will call this Sparkles initial commit, REPL working. And now if we go back to this, we hit F5. Look at that, folks. A couple things we need to do here. Let's get rid of all this. We need to add a README, of course. We need to also add a license. Let's go do that. Settings. No. Insights. Contribute community. There we go. License. No. I know what license I want. I just want to add one. MIT. Submit and review. Commit changes. Put a little gitmoji. All right, we come back here. We need to add a README. Let's quickly go do that. Also, feel free. Here, we're going to drop this in the chat. If folks want to, contribute along the way, feel free to. Actually, let's go borrow. What repo do I want to borrow? Scrabble? Yeah, let's go borrow this. README. And we will pull this down, come back here. I guess actually let's touch readme.md. Oh, we don't need any of this stuff. At some point, if I need a little break, we might go play my Scrabble game. I'm an avid Scrabble player. So we're gonna call this Jello. Is there a Jello emoji? Emoji for Jello? That doesn't look like it. Where is like Emojipedia? What is it called? Emoji. Let's just go candy. What's this thing? Custard? Not really. Have I talked to Dennis Mitchell, the creator of Jelly? We have not, but I think we want to have him on the podcast, but I'm not sure if at a certain point he was giving conference talks, but I think he kind of took a step back from doing public speaking-ish stuff. But he's on our list of people that we would like to speak to in the future. If anybody knows him, let us know. And although I think Adam has had some interaction back and forth with him. Adam's one of the panelists on Raycast. Jelly. I mean, should we just do like, what do you call them? Circles? Circle. What the heck? Circle emojis. I mean, we could just do a couple of these, you know? Red, yellow, green. That's what we're doing. Except, what order do we want to do them in? Let me do that. And we need to reverse it now. Sure, now we need to go update all this stuff. That is a mistake. So that means that on the Scrabble page, if we go back here, if you click on Python, this is going to take you to the Racket website. Oops. Python. Let's go change that right now. Clearly, I just go around copying and pasting all my readmes, which has the unfortunate side effect of having mistakes like that. So this needs to be Python. This is fine. This needs to be Jello. This needs to be Jello. I think the rest of it's fine. Now let's come back to this, copy this, and I mean, I don't think the preview does much here. That's fine. I mean, what we really want is a picture as well. And actually what we do want to do is we want to add the links. Jelly. Actually, let's do this. GitHub repo. I guess we can just do this. And then we want this one as well. Did I spell? I don't think that's how you spell interpret. I think it's with one T. All right, and I wrote Jello Lang instead of, did I? Good catch. that. Good enough for now. Get status. Add readme. So now we have a somewhat functioning. Oh, and you know what we should do now? Go back to the. Nice. And should we put that in there as well? Actually, let's just. Very nice. All right, pretty good. Although let's what is the what's the shebang command for Python? Thank you. Let's go add that as well. So now when we do this, I actually don't need, actually, you gotta what, change the executability, chmod plus x to Jello. So now I can go rl wrap /. Python permission is denied, the F? Oh, it should be Python 3. There we go. Very nice. Let's do that for now. This is recycle. Add emoji plus shebang. All right, what are the comments saying? Picture can probably come later. You wrote Jello, I already did that. You should add a command that displays the translation table. Also, Connor, I'm sure you know, but you can control K instead of typing clear. I did actually not know that. So you're saying I do this, I do my iota rev 10, and then we kill this and I go control K. Control K does not work for me. Control K I thought was when you're in the middle of, say if I want to go back to my commit statement, it'll clear the rest of the line. So yeah, it doesn't work on Windows right now. Although I am in WSL 2, so I don't really know. Anyways, did we push that? We did. The next thing I quickly want to go do is I want to copy from, actually, let's cat it first. Yes. I want to copy my rough file here. And if folks don't know, I mean, rough's like one of the best things to happen to Python in a while. Yeah, this is like all in one. I mean, it doesn't have everything. It's missing one of the crucial lints that I want, which is superfluous parentheses, which exists in Pylint. There's an open issue though, they're working on it. But basically, like, you get everything for free. Like, instead of having to go configure all your lints for Flake 8, isort, Pylint, etc., you can just install rough or just create a rough.toml file. And so now when I go rough.check, yeah, it's going to give me all this stuff. And then I go fix. And next time, I'm done. So I don't even need to be, I probably know that I don't follow all the best standards and whatnot, but it doesn't matter because rough will go fix it for me. And we just want to double check that this still works. Looks like it does. So we did that. Let's add what is this? This is sparkles. Sparkles. I mean, technically there's some CI thing, or I don't know, but this is it's a new feature. We're calling it. Or should we go? Let's go see if there's a Gitmoji. For those of you that don't know, you should always add these things. I mean, what is this? This is like a lint. Fix CI. Add or update CI. Control L is what people are saying. All right, I'll test that in a sec. I think I have, and I have, yeah, the rough extension for VS Code. Yeah, we'll call it this guy, construction worker. Add rough plus fixes. All right, we're an hour and 10 minutes in. I need a bubbly. Whoa! I don't know why I put those headphones back on. I don't need them. Of course, this bubbly is actually frozen because it was in the freezer. I haven't been able to get on the sparkling water train. Honestly, I don't drink bubbly anymore. I got, yeah, what is a requirements.txt? I've had a couple people add those to repos. I guess it's a Python thing. It's just supposed to be the different modules you need. So in our case, requirements txt. But like, is there an automated way, like, or you just have to manually? So what is it, Colorama? Like, I wish, like, you know, your repo or your project should be able to tell. It just stores your pip dependencies. Yeah. So do I have to automatically? Let's just go ask ChatGPT. Let's see which is faster, the chat. You can do a pip R. So the chat was faster. So wait, let's remove that. Although this is still going to be open, so let's don't save. And if we go pip -r requirements.txt pip3. Well, we're going back to ChatGPT. The chat still has a chance. How do you generate file for what the no way. All right, once again, the chat, I think, was a bit, I mean, it was about the same. But that's what I just got from the chat. I'm going to attempt to pronounce your name. It's Yajawal? Might be butchering that. I apologize if I am. So probably need to do Python 3. Holy shit. There's no way I'm doing... What? What is this? Sorry, I also swore. There's no way this is actually. All right, we are going to remove this. We're fine, you know. Someone can add a PR if they figure out the nice way to do this. All right, so where are we at? We're an hour in. We're doing pretty well. We've got our Jello thing. We've only got 2 functions right now. So let's spend the next 15 minutes just building out our monadic functions. And for that, we're going to go back here. So we're going to stick in this land right now. So let's just mess around with this. So A is absolute value. Oh, look, yeah, they added, I hate this about Python is that, you know, technically it needs to have something. So I think if we were to add MyPy right now, it would, you know, be upset about the fact that I'm not dealing with the none case. So we'll do this. And yeah, I guess that's not going to mean much at the moment. Any and all. Return 0 if z is empty or contains a falsy value when flattened. Else 1. That doesn't really make a lot of sense, does it? Any and all? I mean, those are two different algorithms. So if it's empty, any would return false, all would return true. If it contains a falsy value, so at least 1, it returns 0. Else it returns 1. So this is all. I mean, except, what is all returns true on an empty list, right? Yeah. So, I mean, this is just a weird thing then. I mean, is this a... Interesting. I was going to say this. So they must have an all, and then this is like a... All right, so this is what we're going to do. I'm going to take these two. We're going to come back here. So all was the second one. And the first one is really, once again, it's if empty or contains a false value. So it's basically all and not empty, right? I mean, what is a good way? We're gonna change the name of that, but just to check my. Ooh, except how what are literal arrays? And now we're gonna need to go learn something. Is it What a good guess. All right, we've got our little arrays. So if we go all on this, this is gonna be 0, right? But if we go, this is gonna be 1. However, now if we replace our all, this is still going to be 1. But now this is going to be 0, and all is going to be 1. Yeah, so that's all it is. So what's the good name for all not empty? Any suggestions in the chat? So the chat's saying, if I understand, it should be any, like how Python has any and all. No, because any would return. Ooh, I put a space. Shouldn't have done that. Any would return true for this. Whereas this one, as soon as it sees one non-falsy, one falsy value, it returns a 0, which is the semantics of all. So it's just like an all prime. Let's go. Once again, we're going to play Chat GPT versus Chat. What is a good name for a function all that is and reduction, but returns what is it? False if empty. Probably a poorly worded way of those were all terrible suggestions. I mean, should we just call it all not empty? Thing is, if we're going to start giving verbose names to these things, kind of defeats the purpose of this whole thing. Yeah, well, screw it. We'll leave it like that for now. Back to Jelly. Okay. B to I to B, B to I. And then this is bit. Isn't it a better... So wait, well, we definitely want all three of these. So the first one was I to B, right? Although, I guess we just have to know that B stands for they're calling it bit. I'm pretty sure this is odd, though. If I'm not mistaken. I mean, it's the same thing, but I prefer the name odd. Here we go again. So if I do iota odd 10, it's exactly what I would... Actually, wait, what iota 10... I never actually noticed. Is it one index? It's one indexed. Okay. Okay, that works. To binary, though, what's going to happen if we do iota I to B? Ooh, look at that. And then we can go B to I, right? Ooh. We're going to need to add some exception handling here. All right, that works. Let's keep going. Should we do the whole alphabet, or should we should give up at some point and complement, aka not seal? I mean, those two are easy. Amato says all underscore NE, not empty. NE typically means not equal. At least when I see E in short form, like you see it in like GTE, GT, and LTE and LT. It's a decent suggestion though, but Matan says maybe full, like filled with non. That's actually a decent suggestion. I like that. Okay, I finally get what you mean. Sorry. You should probably store these in a dict. I mean, I don't think it's really gonna. I don't think the perf of this is gonna suffer, but we can do it if we need to. Anyway, some other suggestions. Let's check to see that these work. What do I want? I want 1 odd 10. So then if I go 1 odd not 10, it's exactly what I would expect. Ooh, and what was that? We had that function t, which was, yeah, so t is either replicate or indices. We call it IDX. So let's add that one, because now what we can do, QRSTUV. Let's call it IDX, and this will be T. So now when we run this, we can add IDX to this, and then now it's, yeah, that's really nice. I really love, and I think, yeah, we already covered that earlier, that in WeWAPad, they added, I guess I deleted it, but they added keep, which is the moral equivalent. It's a binary function instead of the unary function that's in BQN for replicate. But that's great. I mean, okay, let's keep going. We're gonna get to the interesting stuff. I said we'd do 20 minutes of this. Coming back here, integer to decimal. We'll skip these. DQ. Return. Oh, that's a nice one. We're doing that one for sure. So does anybody know what the name of this one is in Haskell, which is the name that we're going to use here? Yeah. That is Sherlock Sage had the correct answer. Even before I asked the question, it is tail. And I imagine that means we have head as well. I mean, so I guess technically Haskell doesn't call this tail. They call it a knit. Or no, it's head and a knit and tail and last. So yeah, maybe it is. Ooh. Wow. Does anybody know why I just went, ooh? That's great. This algorithm has a special place in my heart. I mean, we'll call it all equal. Does anybody know why? Nobody knows why. It's because algorithm as a tool of thought. I gave this talk how many years ago at this point? 2 years ago? For folks that are interested. And basically in this talk, I go on to show 8 different, I think actually at the end of the day, oh no, there was 8. Yeah, the last 3 were recommended by other people of 8 different ways of implementing this in APL. And at some point, I think I remark at the beginning of the talk that, yeah, this function actually only exists, at least that I could find, in Haskell and in a Python library called more iter tools. And I think technically there was a JavaScript library. Oh yeah, I have this. There's a JavaScript library that called BBO that has it as well. And you can kind of enclosure and racket get things similar to it. But I think it's a very useful thing that comes up every once in a while. That is not trivial. I mean, it is trivial to implement, but it takes up noise. And like, I would rather just have something called all equal. Anyways. Yeah. What is Matan says? No one makes a lecture about a whole algorithm. I mean, I am very fond of this algorithm, but more the point of the talk is that just like the power of APL is that you can quickly build this stuff up. But like, you know, how would you, if we go back here, if we kill this, we open Python 3. If I want to implement this, it's going to be like, how would I do this? You know? I mean, technically, the easiest thing to do here, let's create a list called 1, 1, 1, is if I just go set x and then, you know, length 1 equals, like, that's probably the easiest way. But, like, there's a bunch of different ways, and it becomes, like, this one's easy to spell. But if you're going to do it in Python, you could technically do, like, all of A equals B for A comma B in zip of X so this works, but like, you know how that's like that's very painful to spell, and to do this in APL, which one was it? It is this one basically. You know, it's 5. What is that? 6 characters. Like compared to having to type all this out. Anyways, digression over. We very much like all equal, and we have it now. So yeah. Crazy that that's like, this is the expression. And so how do we get this to return? We could technically add a odd in here, and then it's going to be true, right? Sherlock saying, by the way, if you want, I think I have the longest jelly algorithm on CodeGolf Stack Exchange, and I can link it if you'd like to see. Sure, yeah. Throw it in the chat. We can add it to the links on the README. And what is... I'm going to click this heart just so I can try and get rid of it. There's this like emoji in the bottom right-hand corner of the chat, and it's obstructing the text. All eq would be better. Yeah, sure, we can... yeah, it is kind of true that, you know, all... What's the opposite of not empty? I know Haskell calls empty null. Or wait, someone I think is saying that they have... FYI, I'm successfully running Jello in macOS Shell Python 3.9.6. Evandro is saying, I can't get rid of it even with Element Zapper. I have no idea what that's a reference to. Maybe a comment I missed earlier. EMP, someone suggesting. Yeah, I don't know. I'll keep noodling on it. Shouldn't be trying to lose too much time. Anyways, let's get rid of this. Let's go back here. Any. Enumerate. Ooh. Those are both great. So call this any, and that's going to be the underdot. And the second one is enumerate. What do we want to call that? Zip index is my preferred. I mean, zip with index I like better, but so let's go back to this and then go zip index. Ha ha ha. Isn't that nice? Love it. Love it. Yeah, I know enum would be short for enumerate, but enum is such an overloaded thing. And I also have like, I think K calls iota enum, and that ruffles my feathers. Yeah. C4 Tubo saying that it's the most overloaded. I'm not sure if it's the most overloaded, but it's ridiculously overloaded. Yeah, we're gonna avoid it. And I think it's a tragedy that K calls their iota, like iota index generator till, you know, the number of great names for it. Enum is not. That's a terrible name for it. Oh yeah, he says I was joking about it. All right, let's keep bopping along here. Let's go to the G's. Maybe we'll make it to H, and then we will. Then we're gonna hop over to learning about chains, because that's where things are gonna get interesting. Attempt to format Z as a grid. Well, let's. I have no idea what that means. Ooh, except we kind of messed up our order here. There's a protest. You probably can't hear this, but there's a protest that's happening outside. I'm in Toronto right now, and we don't know what they're protesting, but so we're going to call this grid. And let's see what it does. Let's clear this. So grid. Oh, that failed. So let's just go iota 10, iota grid 10. They're protesting the use of my underscores. I mean, yeah, we could get rid of them. It doesn't really matter. I know you're probably joking. Is there a GitHub repo for Jello? Yes, there is. Let me grab it. Oh yeah, and also, I don't have the little contributions welcome tab. That's sad. In fact, what I should do is I should go and add this to the video description, but I'll do that after the fact. But let's go. What's one of my? Here, let's get rid of some of these tabs here. Get rid of this. Get rid of this. Get rid of this. We need ChatGPT. Which one of these has the? This one does. Add contributions, welcome, badge. All right, just message me in the chat when your PR is there, and I'll be happy to review it / merge it. All right, I'm just catching up on the chat. What are we doing? We were trying to figure out what grid does. Attempt to format Z as a grid. Group the indices of Z by their corresponding values. Okay. Is this, I'm trying to think which, there's a bunch of groups. So let's put a, don't know what this does, but we'll figure it out. And actually, I need to give it an actual name. So if we have iota, and then we go odd, then we go group. Yeah, that's nice. So this is basically like replicate or keep, except it operates on Boolean values and keeps both. So it's kind of like a partition almost. We can call it group though. I'm fine with calling it group. I mean, partition, group, key, cut, they're all different flavors of each other. What did we say? We said we get to H, right? All right, so the H's are half, double, and head. Ooh, do we call it double? Kind of seems long. I mean, it's not as long as zip index. And I guess that's kind of like, you might be thinking that we're kind of defeating the whole purpose of this language, because if we have a multiplication, now the alternative is like 2 times is going to be way shorter than double, so why would you ever call double? But you know, this is for pedagogical purposes. We're learning here. We're learning and teaching, and if we're kind of destroying the purpose of this language while doing that, you know, it is what it is. Half, double, and I believe head was the last one. So let's kill this. Clear. So if I go iota, reverse head 10, and then I go half, and then I go half, and then I go double. All right. So let's stop there for now. I mean, we're not stopping the stream. We're stopping converting monadic functions. And we're going to go learn about chains now, which is going to involve reading the tutorial. Maybe it might be less exciting. So sparkles. Add a bunch of all right, we're bopping along. So now is going to be story time or whatever. I don't know if I'm going to read this out entirely. But we're going to go quickly through this. You define links by composing existing links into a chain without explicitly talking about arguments. We love that. We love point-free programming. Which way the arguments flow through this composition is defined by the patterns the links are arranged in. An example of this will be given soon, but first we'll need to introduce some concepts. Arity, we've already talked about. Monadic, dyadic, niladic, done. Yes. Adjectives. So what's the arity of the links we define when writing a program? By default, they are variadic. That is, it's up to the caller to specify how many arguments to use. Uh-oh. That kind of sounds a bit like ambivalence, but at least not the functions that are provided. So as an example, plus h is a chain of addition and h half. As the respective arities of the elements of this chain are 2 and 1, we call it a 2-1 chain. So yeah, this is what's very exciting, because I've not come across this kind of thing before. The interpreter has specific rules for breaking down chains based on their arities. Those rules dictate that given a single argument n, this new link computes n plus n divided by 2, which you can read plus h as plus itself halved. I mean, so this is technically the B1 combinator. It's backwards from array languages. Oh yeah, so let's combinatorylogic.com. This is my website. Huge combinatory logic fan. If we go to the table here, what was just communicated was that we're applying a binary function first and then a unary function afterwards. And that is the B1 combinator, the Blackbird. It's a 2-train in both APL and BQN, and it's known as... I actually don't know what they call that. What is BQN? Did they just call it a top, is what APL calls it? A top, yeah. It's a bad name. Back to this, though. If 2 arguments were passed to the program instead, the link would be a dyadic chain, and it would compute a plus b divided by 2. So actually, wow, that's confusing. So I misspoke. Technically, So what is this then? So what's happening here? Let me talk through. So they're talking about this plus h, which in my program is going to be plus half. So the tutorial says that basically the arity of this function or link is going to be determined by the number of things that you pass it. So in the case where we pass it 10, this is going to evaluate to 10 plus 10 divided by 2. So really what this is when you only give it one function, it's applying the W combinator to the binary function plus, which turns this into a unary function. And then you have 2 unary functions, half and double. And 2 unary functions composed is just the B combinator. And when you are passed 2 arguments, then it's going to be 10 plus 20 divided by 2. And this is an example of the B1 combinator, because you're applying the binary function first, then the unary function afterwards. So I don't actually know what to call the... Yeah, technically this is an example of, ultimately, of the B combinator at the end. Because due to the way that this is evaluated, this plus actually acts as a unary function, which I do not know how I feel about. What is the comment saying? Commit the latest source, please. I think that was a couple minutes ago. I came too late to enjoy this. It froze on my end for a little bit. Sounds like the interpreter is automatically deciding that a single argument pass should be replicated. That's exactly what it's deciding, which is what the W combinator is. So, I mean, if we go over to, let's go over to BQN, because we can just type this out in BQN. So, you know, technically, you know, we're gonna have to put this in parentheses. So actually, we're gonna need a function called h, which is gonna be half. So the way we can do this is by partially applying 2. So now we've got, and it's going to be right to left now. So when we pass 10 and 20, because it needs to be infix. I mean, it might be actually better to do this in Weewa, because Weewa is all prefix. We get these, this is the second sort of spelling of this. Second spelling. In order to get the first spelling, which is where you're duplicating the argument, we're going to need to, and also we're going to need to we need to add the W combinator here. So in this case, because this function is going to end up being called monadically, this acts as the W combinator. Actually, I guess we can do it like this. So this is the first spelling. Anyways, how I feel about it doesn't really matter at the end of the day. That's what's happening. You can change the semantics of... I mean, so actually, what do the docs say, though? Where's the plus? I mean, yeah. We're going to see what the implications of this are, but like this, maybe everything at the beginning that I said about ambivalence isn't true, because it's saying that this is a dyadic function, but we just saw that in this example, when you pass a, what is it called? A 2-1 chain? Yeah, when you pass a 2-1 chain, only one argument, it does duplication. So there's an implicit W combinator. So maybe it's not that this is the way that plus works. It's just the way that any 2-1 chain works, is that if you have a 2-1 chain, so I believe that the arity of the first function in your link is going to kind of define the arity of your overall link. And you only pass it one argument, it just does this duplication. Anyways, seems a bit confusing. Yeah, C4 Tubo is saying, the interpreter is allowing the same expression to be called differently, one argument or two, without adding the W combinator. It does it for you. It's not ambivalent, but from experience, the way in which the arities I can't even read it because there's an emoji in the freaking way. YouTube, fix this. I'm going to put a... that is just to move the text up so that I can see. To resolve can be hard to figure out mid-code. All right, well, let's keep going. Jelly programming, then, is essentially the art of learning these rules well and composing clever chains to get the job done tacitly. All right. Each line in a Jelly program is a link definition. Links are basically functions. The bottom line represents main. It's the link that gets evaluated using the arguments passed on the command line. All links but the last one, then, are function definitions. You can refer to them using quicks, which we'll elaborate on later. So I'm guessing that these are like top one, copy link result to register, this link with the same arity, last link as a nilad, last link as a monad. I mean, I'm not sure how much we're actually going to get into this. What I'm mostly interested in is like single line expressions. But We're going to come back to it, so it doesn't matter. For example, whatever this is called is the link above this one as a binary operator. Above really means the line above. Consider this example program. Okay, I'll zoom in for folks. We got plus the thing above binary. So my guess is that this is a 2-1 chain that's going to add and then square. Let's see if I'm right. Which computes the square of the sum of its arguments. Right. And because this is specifically stating, embedded in this glyph, is the fact that you want this as a binary operator, the quote-unquote ambivalence doesn't exist because you're saying it has to be called dyadically. Okay? This is sort of like the pseudocode. Okay, sure. We need to describe, of course, syntax. We're moving on. Of course, what characters can be used in a chain definition and what they will mean. Jelly uses its own 256-byte code page. Most of the characters in it are allocated for built-in atoms, but some of them have special semantics. Jelly values are either complex, float, int, list, or characters. Literals are always nil-adic. I don't think this stuff is super important for the moment. We're gonna skip the string section. List terminators. I mean, we already know how to. We've got our one list. You know, we'll come back to this if we need it because I want to get to the chain section. Very cool language. That code I linked is actually a 4-line expression because I really needed to refer to the other subprograms multiple times, which is a pity. Needs less Latin. Unfortunately, Dennis's of this author is Latin American, so that's unavoidable. Interesting. So that's where we get the diacritics from. All right, on to what we are here for. Section 4, chains. How does Jelly evaluate a chain? As explained before, there are 3 cases to consider, whether this chain was called nil-adically, monadically, or dyadically. A nil-adic chain. These are the easiest of the bunch. To evaluate a nil-adic chain that starts with a nil-ad, like alpha FGH, evaluate the monadic chain FGH at the nil-ad alpha. Caveats. If the whole chain is empty, 0 is returned instead. If alpha isn't a nil-ad, evaluate the entire chain monadically at 0 instead. I mean, no sense. For example, 4H is just H evaluated at 4, which is 2. Mm-hmm. That is a bit confusing. We'll move on though. I mean, I think I understand this, but what I'm thinking in my head is like, okay, I mean, we can already in our program here, if we go half 4, that's just H. But this is saying that if you have a niladic chain, you can, I guess maybe that is if you're building a program. I don't know. Well, I think it's, you know, this is all in the context of multi-line programs. But I guess 4H as a, whatever, sub-expression of a larger program would evaluate to 2 as well, which is fine. Okay. Although this part where it says, what is alpha? Let's go find what alpha is. Where's alpha? Is there alpha? Nil add. Anybody see alpha here? I do not see. Or actually, wait. We can just. He might be just using it as a variable name. It is not on the page, according to search. Alpha is the marker for the left argument. Maybe it's for expressions that are essentially calculated constants. Omega is the right. Ah, I see. Okay, it's just notation that he uses for the documentation. Gotcha. All right, well, I mean, we'll come back to niladic chains. Monadic chains. Monadic chains are broken down from left to right until there are no links left to consider. Also, we're past some argument omega here. There are 2 questions to answer. What's the starting value for this left to right evaluation? If our chain starts with a nilad alpha and is followed by 0 or more monads, dyad-nilad pairs, like +2, and nilad-dyad pairs, like 4 times, we start evaluating alpha and then consider the rest of the chain. What? Otherwise, we start from the argument passed to this chain. Okay. How do we walk down the chain? So I think it's just saying is that we can kind of have an argument on the left, aka a nilad. And if we do that, we start evaluating alpha and then consider the rest of the chain. So I don't know if that means actually that you start processing things left to right instead of right to left. But when it's not the case, which is what we've been dealing with, it's just this. This makes sense. And Sherlock Sage is just saying the notation comes from another language. I mean, APL uses alpha and omega for their arguments. So, I mean, it makes sense that in the documentation, and Jelly was inspired by J, and J is APL 2.0. So how do we walk down the chain? Let's call V the current value. Initially, it's the value described above, but it gets updated as we go through the chain. And the note. Oh, you know, maybe that's what we should do. How easy is that a change right now to make? We should actually do that. I think this is pretty straightforward. What I want to do is I want to add a trace, and it's only going to be a couple lines of code, I think. So we can do this by, I don't really want to use a for loop. But we can for now. Actually, forgetting what language I'm in. We want to go 1. Actually, we want to go. Can you go backwards in these things? Len of expr actually, what's the right way to do this? And I don't even know if I have to put like a -1 step in here, but we will. And then I want to go just print. And I guess actually we want to do this. We want to do this in the converted expert one. Print. And we want it to I. So yeah, we need range 10, 1. Yeah. Not what I wanted. So I guess I want it to go up. I don't know why. Oh, I'm still in the program. So now, if we oh, whoops. Nice. Kind of. It looks weird than what I would expect a trace to be. And I can never remember, how do you print in Python without a new line? Yeah, end equals. Okay, stop. That's all I want right there. There you go, left arrow. What is going on here? Left arrow emoji. I don't want the right one. Copy. So we do that. Actually, we need a... Actually, what am I doing? We don't need this up here. We... need this here. Right. What? Why, I have my falses and trues mixed up. I mean, that's kind of irritating as hell, though. That, what's the chat saying? Yes, it was backwards. Should we go get a left pad, right pad function? I mean, I guess we can just write it ourselves. Is there a left? What are we? We're padding from the right, though. A right pad function in Python. Ah, there is indeed. Ljust. Oh, actually, I'm doing this wrong. It's Ljust length. This is getting pretty ugly. And now we don't want this, do we? And we also don't want how come half 4 gave us nothing, though? You just entered. Jelly is a array programming language. Chat is in the link is in the description, and we are basically building a tool to make it easier to type, understand what's going on. And right now, I'm just building a trace. But I think I have a small problem, which is that this might need to be +1, off by 1 error. And half 4. Except now I realize that's why we had that. Yeah, there we go. And then half 4 should be that. I mean, all right. That'll help us a little bit. Clear, get status, get diff, rough fix. We will call this sparkles add trace. Very nice. Look at that. Still no stars. What are we doing, folks? There's like 30 of you here. You should all go start. All right, back to our tutorial. How do we walk down the chain? Let's call v the current value. Initially, it's the value described above, but it gets updated as we go through the chain and denote. Nil adds using digits, monads using uppercase letters, and dyads using operator symbols. Then the following patterns are matched from top to bottom. So dyad, monad, ... is your left argument prefix dyadic operator and then a monadic operator, a monadic function. I shouldn't say operator. The symbol is an operator, but it's a dyadic function. And then the monadic function is applied to omega? So let's try this out with plus square multiply. Plus isn't a nilad, so we start out at v equals omega. Then we chop off plus square, matching the first pattern, and get v equals w combinator on a dyadic function with a monadic function afterwards, which forms a monadic function. So then we move on to the multiplication, and we get, and so at that point we've got a 1-2 chain, and so this is a 2-1 chain. This is a 2 nilad chain. This is a nilad 2 chain. This is just a 2, and this is just a 1. I mean, this does not parse. At least not for me. Amato says, would be, or C4 Tubo says, would be nice for the trace to show the argument to the expression. Yeah, we can add that. And for the trace, I think it would be nice if it looks like consuming tokens. Amato says, for the trace, I would think that it would be nice if it looks like consuming tokens. Oh, I see. So you're saying yeah. I'm not sure about that. I see what you say, because I think that's how like the trace typically works. But the fact that you're kind of skipping the argument over all the other functions, I don't think was, yeah. I don't know how I feel about that. We can definitely add the plus. What am I doing here? This should be an F string. In fact, I'm surprised that Ruff did not tell me about that. And so we need one space, then arg, Where's the mismatching paren? Oh, yeah. Ooh, can we do an F string? What is it whining about? You might not be able to do an F string. Escape the inner quotes. Oh, yeah. Thank you. Hey! Right, we passed this in, don't worry. Don't need the plus. Yeah, that's fine to me. I mean, maybe we should color it something differently, though. Yeah. So... And now, actually, this needs to be false. What color do we want it to be? Pink? Purple? Blue? Wait. Did I implement that function wrong? Stewart's, what is that? Stewart saying value colon less than 10 to justify with a length. Oh, snap. Are you serious? What does that actually, how does that, like what, give me the exact line of code because I don't, actually, you know what? Let's just go ask ChatGPT to refactor it. Hey, I know F strings support padding. Can you refactor this to do that and avoid the L just? Thank you. Isn't that goddamn amazing, man? People saying ChatGPT not changing the way we work. I don't even know, you know? Stuart mentioned it. I don't understand it. I mean, I understand it, but I don't know the syntax. And there you go. Absolutely fantastic, folks. Do I like blue? I don't really know. It's fine. /T for the tab. I don't understand what that means. You mean here? I kind of like spaces better than tabs. Yeah, it's way too big. We're going back. Spaces are better. All right, what did okay. Actually, wait, we should git commit. We need to call this recycle add arg plus cleanup trace. How's the repo doing? How many starts did we get? Wow, 3. Feels great. Thank you to everybody that starred. And also we should go bold. Bold that. All right, let's go back to the tutorial. I mean, let's read this again. We chop off plus square. And that is our 2-1 chain called monadically, which gives us this pattern. All right, that makes sense. Then we chop off multiplication, matching. All right, and so this is the first pattern. This is a 2-1 chain. I don't know why there's, you know. All right, we're gonna go do this. We're gonna do this ourselves because this is not good enough. Should we just put it in the README? Why not? Let's put it in the README for now. Chain pattern, new value. I guess I could have just copied the actual markdown. That would have been easier. Whoops. Chain arity. So we're going to call this a 2-1 chain. We're going to call this a 2-0 chain. We're going to call this a 0-2 chain. We're going to call this just a 2, and this is just a 1. Preview. I guess we should put descriptions on these sections. Just do this. Actually, let's just call it links. What are these called? These are called, we're just calling these chains. So chain parsing patterns. Doesn't really matter. Okay. Interesting. Emoji parsing. Yeah, I think WSL2 messes a lot of that stuff up. Let's go back here. So we match with the first one. Then we match with the fourth one. 1, 2, 3, 4, 5. So we match with the first one. Then we match with the fourth one. I do not understand that. Because... Oh. I mean, no, actually, I still don't understand it. Because if we are evaluating this... So the question is if when we have this whole thing, we're not evaluating it at any point, right? And that means that we're building up this composition pattern. So technically, after the first step, this returns you... And also, it's very unclear why omega is here and we've got v here. Because then it says that omega is v, so it's omega omega. But anyways, this is a unary function at the end of the day. So now we've gone from a 1-2 chain to another 1-2 chain, no? Like why do we skip to here? Why are we ignoring the unary function that is returned by this pattern? And then finally, the chain is now empty. It is? So once... Let's go back. Let's go back and read this again. Monadic chains are broken down from left to right until there are no links left to consider. Also, we're past some argument omega here. There are two questions to answer. What's the starting value for this left to right evaluation? If our chain starts with a nilad and is followed by 0 more monads, dyad, nilad pairs, and so interesting also too, add this to our table. So plus 2 in this case is number 2 here. So we've also got these names that, name. So this is a dyad nilad and a nilad dyad pair. This is such a awkward way to, but I guess APL doesn't do any better in this situation because they have these kinds of things too, and they refer to them as AGH forks, where GH are functions and A are these nilad scalars here. And so I guess this would be a dyad monad pair. So my question is, where is the monad dyad pair? But hey, maybe we'll get there. So if your niladic alpha is followed by 0 or more monads, dyad nilad pairs, or nilad dyad pairs, we start evaluating alpha and then consider the rest of the chain. Let's call V the current value. Initially, it's the value described above. What value? Alpha? What value was described above? I'm going to assume he means alpha. But it gets updated as we go through the chain. Okay? We already got this. Nilads are digits, monads are uppercase letters, and dyads are the operators. Then the following patterns are matched from top to bottom. All right. We got this. These are the highest priority ones at the top, then lowest. So let's try this out on the chain plus square times. Plus isn't a nilad. So we start out at V equals omega. Okay, so we've confirmed that the value described above, aka alpha. Never mind, sorry, omega. Jesus. So V equals omega, which is whatever argument we're passing to our program. At any point, I guess we're just pattern matching at this point. So we go to the top and we look for the dyad monad pair, which we find in plus square. And then we evaluate this to get our answer. Now we've got a new omega, and all we have left is a binary function, which is why we match on the fourth time. I see. So this is actually closer to like a stack program where we're taking functions at, a certain number of functions at a time, evaluating, throwing our answer back on the stack, and then proceeding. Okay, I understand now. Does everybody else understand? I've been ignoring the chat. I took the liberty of converting to a dict. I hope that's okay. Yeah, that's fine. Is there a PR? Well, there's no PR, so. But that's all right. Seems like alpha is just a constant value in the expression, not an argument. Maybe. I think I understand this though. Basically, so if we come to our little scratch pad here, so we've got plus, square, and times, and then this is going to form some program, but we'll assume, actually let's just do it with the number 2. And so now we've got this. Let's move this over here so I can toggle back and forth quickly. So we've got this table, and so what we're going to do is we're going to pattern match on this table. And the arity of this is 1, 2, 1. So the first thing we try and check is, do we have a dyad monad? We do. So now we're going to take these two, we're going to take it with our 2, and we're going to apply the valuation. Now we know, because we read earlier above, when you have a 2-1 chain, it's actually, we're going to leave this here, but henceforth we're going to refer to, and actually we don't want to call it chain arity, we want to call it chain type. And actually, this table is really frustrating. We should just call this what it is. 0 are the nil-ads. But anyways, we'll leave it there. We'll leave it here. But that's kind of, this is the correct way. This third column here that I've added. We've got 2-1 chains, 2-0 and 0-2 chains, which are what they colloquially, in the text are called dyad nilad and nilad dyad, and then just a binary function or a dyadic function and a monadic function. Anyways, coming back here. Because we have a 2-1 chain here, 2-1 chain called monadically, it's going to apply the W combinator here. Then you're going to double your number. This is going to become 4. You're then going to square that. So this is going to end up giving you 16. And now we're going to move on. All we have left is multiplication. Once again, multiplication, my guess is that when called monadically, with the value 16, is going to apply the W combinator again, and you're going to get 256. So let's go, folks, and test our theory. Actually, I'm incorrect because we know that, what the F? That's so confusing. So the multiplication, so we're not replacing our omega. It just becomes our left argument. So then you end up with this, where plus in this case is multiply. So I was correct up until the point that this is V. And then this becomes V times 2. We'll call X. X will be our, because I don't have omega. Actually, we'll call it W, because that's closer. So let's check that. I mean, this is proving very. So if we go back here, we type this, we pass it to. Still was wrong. 2 plus 2 is 4. Squared is 16. times 2 should be 32. No? What did people think that this was going to evaluate to? And also 2, wait. 2 plus 2. Oh, 2 plus only 1 2 is squared. What the F? Didn't we just go through this? When you have a 2-1 chain, so everything I said before was wrong. I mean, honestly, no offense to Dennis, you've created a very interesting language. But come on, my guy. If you're going to have a language that parses left to right, and then you're going to have an expression that relies on PEDMAS, that's not on me. I read this. I mean, we should be making commits, pull requests on this document here, clearing up our confusion. When he's talking about this, and actually, I mean. So this is all wrong. This is all completely wrong. This does not evaluate the same way that Jelly does. This evaluates like PEDMAS, which. All right. So, holy smokes. Let's go back and revisit. What are we at? We're at the 2-hour mark. When did we start this? We're almost at the 3-hour mark. Jesus, I need another bubbly. I'll be back. Oh boy. We might take a little Scrabble break in a bit. I also have to order food in order to sustain my mental acuity. So, this was incorrect. Plus half 10 is really this, which means what? So let's actually write this out. We've got f, which we will be calling a unary function. So actually, no, we've got g x f x. So I actually think someone said that. Yeah, actually, Nathaniel Lundberg, you said like a J hook. That's actually correct. This is not. So actually, let's go back here. Perfect. Now, see, now we're actually making progress. Now that my immense confusion, this is the S combinator. You apply the unary function to your argument and then pass that along with the initial argument to our binary function. That is explicitly S. It's exactly what S does. In the binary case, it is still B1. Look at that. So we were only, so actually, geez Louise, we need combinator in monadic case and combinator in dyadic case. How are we going to do this? C1. Actually, no, wait. Combinator. Actually, yeah, let's just do this. Superscript 1. and superscript 2. And oh no, I gotta reply to a message in a sec. Combinator in monadic case combinator you just square the second 2, not the addition. This is what I mean about arity solving weirdly. Hooks and chains and forks make my brain hurt. Yeah, unfortunately, Dennis. Yes, you're confused. We're all confused. All right. While I respond to this text message, you guys can play Scrabble. I mean, we'll play Scrabble together. What's the best word here? Up something? Up. Ooh, is up beam? That can't be a word. Beam me up? I want to get rid of the PU. Maybe I should just spell pub. Bumps. That was the best. Do I know Roto? No. All right. I gotta reply. My phone's blowing up. But message in the chat what you think the best play is, and we'll see who figures it out. Give me a couple seconds here. All right. I gotta turn this on though. So, no suggestions. 33 concurrent viewers. Not a single Scrabble suggestion. I was gonna say moose. Not very good. Moose. Still not very good. Should we just play? Technically, is a word. MM. Oh, sorry, I was working on the PR. I mean, it's what we're here for. Gotta take a Scrabble break every once in a while, though, you know? Poem? Poem is decent. Doesn't make the top 14, though. What is Moz? Emos? All right. At least we're scratching the top maybe we should just play Moo, though. What are the best words? Seam? Mems? Momes? Mesa? Memos? That would have been a good one. Ammos? That would have been a good one. All right, we'll do one more turn. I do know the word welding. Oh, yeah. My computer program is very good. Gamesh. Shag. Is heem? That's not a word. Yeem? Yam? Damn. Meshy? Mashy? Mashy, that's a pretty good word. Meshy? Meshy's a good word, too. Mashy. It's probably the best we're going to do. Mayhems. Wow. A double-double for 68 points. All right, let's go back to what we were doing here. Heme is a word. Actually, wait. People were actually suggesting things now. I thought no one was suggesting anything. All right, we'll do one more, and I'll wait for people to... Logger? Regula? Regule? Regale? Does anybody know? One of the top two words is better than regale? Unreal? That's definitely a word. Doesn't scratch the top 14. Regular, we need an extra R for. Regular under rotor? Yeah, that's not going to hit the triple word score though. And also, we need a G too, which is from over there. Regale. Oh, the G. Yeah. Is area? Can we spell area? I don't think that's going to get us up there, though. Areal? A real? What does a real mean? A particular extent of space or surface. All right. We're going to go with regale. Regale. Leaguer. To besiege. Lari, a monetary unit of the Republic of Georgia. Yeah, why didn't anybody get that? All right. Fives. I know that. We'll come back. We'll play later. Ooh, look at that. I got the blank. Fantastic. Moving back here, though. We've got things going well now. How's this markdown file looking? You know what? I wasn't going to go and do this, but I kind of want a subscript one as well. Subscript one. Because it looks nicer. All right, so we've parsed this now. And If I am correct, that means we have also been able to parse this. Go back down to the chain section. We've also been able to parse this. So this becomes a 1-2 chain, which is the S combinator. Then this becomes V, and then this and this, they're nothing. They're just function application. So let's go update our little table. So we're just going to put a little heh and a heh and a heh and a heh. Fine, easy. Let's keep reading then. Ooh. Here we go. Leading constant change, sometimes for certain chain parsing patterns. Chain parsing patterns. Are they called chain patterns or chain parsing patterns? CPP or CP? To match, a certain part of a chain has to consist of a nilad followed by a list of monads and dyad-nilad-nilad-dyad pairs. In other words, the arities of the chain segment had to match the regex start of expression 0 paren 1 or 0 2 or 2 0 end paren end of expression. Such a chain is a leading constant chain, an LCC. It starts with a nilad that can't possibly be part of a dyad-nilad pair and therefore must imply a new constant value. For example, 5 is a LCC, but 5 plus isn't. Sure. We're going to move on, folks. Just remember, if there's some non-pattern match, there's a special case called an LCC. Dyadic chains. What did I call these? Well, I mean, and actually, what were they called before? Were they called monadic chains? They were called monadic chains. That's true. So chains. Let's go add chain patterns. Monadic chains. Then we're going to add dyadic chains. These are basically like monadic chains, but this time there are two arguments, lambda and rho. What's the starting value? If the chain starts with 3 dyads, we start at evaluating the first dyad and then consider the rest. Otherwise, if the chain is an LCC starting with a constant kappa, we start from V equals to kappa and consider the rest of the chain. Otherwise, we start from V equals lambda and consider the entire chain. Holy smokes. How do we walk down the chain? This time the patterns are all right, folks. This time, should we go and get, let's just go and get the markdown. Ooh. For a second, I thought that was going to instantly fork the project, but it doesn't until, all right. Let's cancel. How do we get rid of this? Cancel. Let's go back. And we're coming back here. We're now dyadic chains. I can tell this is going to be a long stream, folks. I guess we should go make these match. It's odd that it's, oh, right, I see. Interesting, actually. I don't think I've ever used a non-centered markdown thing. So, and there's a star next to this one. So I mean, we're gonna just do the same thing we did before. Chain type, and we're gonna call this is a 2, 2, 0 chain. This is a 2, 2 chain. This is a 2, 0 chain. This is a 0, 2 chain. This is a 2, and this is a 1. So let's see if I can guess this. And I mean, there is no monadic case anymore, right? I mean, hopefully not. Actually, why did I do that? I just want... So now we have a dyad, 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 nilad, dyad, nilad, nilad, dyad, dyad. I guess these ones don't have them once again. All right, so we're applying in this case the first binary, the first dyad, followed by the application of the second dyad with a constant. Which is the eagle? And what's interesting, this table is missing sigma and delta, which are the analogs of S and D. I've never needed an analog for E. Is there another? There's eta and there's epsilon. Let's go ask ChatGPT. What are the Greek letters that start with E? Epsilon, eta, epsilon symbol, those are the same thing. So epsilon and eta are both correct. Eta would be probably what I would call it. So does this make sense to people? You've got two binary functions here, A and C. Your two arguments, D and E, which are going to correspond to V and rho. And then your niladic, I don't know, what did they call them? Values? Or they just call them nilads. The nilad here is a constant, which is going to correspond to the B. And yeah, in the case of, I mean, what is lambda again? You've got lambda and you've got rho. Lambda is the left argument, rho is the right argument. So let's look at it this way. So where's lambda here? Maybe that's what the star is for? Stars, only if 1 dot 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 is an LCC, i.e. 1 is a constant. Sure. I'm still confused on where lambda is in this expression. Whereas this one, I think that's what's most confusing about this, is that I mentioned this before. It's kind of like Weewa in that this V is kind of like a single argument stack. And so you have to contend with keeping track of, in monadic chains, you've got V and you've got omega, aka your argument. And then in the dyadic cases, you've got V and you've got lambda and rho. And depending on the parsing of all this stuff, you know, you may or may not need lambda and you may not need, you know, omega right away, which is what I think this is kind of trying to explain. It's saying, you know, in the otherwise case, we start from the argument passed to this chain, aka omega becomes V. So that's like pretty straightforward. But if your chain starts with a nilad and is followed by 0 or more monads like H, you know, 2-0 chains or 0-2 chains, or 0-2-0 pairs or 0-2 pairs, I guess segments you can call them, we start by evaluating alpha. So then alpha becomes your V, and then consider the rest of the chain. So at some point, you're going to switch from ignoring omega to taking omega into account, which is not really clear how that happens. I guess probably once you become familiar with all these patterns. And yeah, then in this example, you don't need V to, like, you're not in this case. We're in this case. And so then you come down here and it's the same thing. So now it's even more confusing. So this star only, so let's just walk through this example. I'm pretty sure this is E though. I'm pretty sure this is E. We're gonna call this eta because it's the analog of E. And that's it really. The rest I think are pretty straightforward. Let's try out the chain plus times divide H. The chain starts out with 3 dyads. So we start at V equals lambda plus p. So we're just evaluating p because we match this rule. And then we throw away the plus. So now we have v. We'll assume both of our numbers were 1 and 2, so now we have 3. Then we chop off the next two because we failed to match on the first one. We pass on the second one, and then we get interesting. I mean, and this famously is the phi1 combinator, aka the dyadic fork in APL, J, and BQN. Sure. Then we chop off H, matching the sixth pattern. I mean, the fact that he is not using parentheses here is just mind-blowing. Because he was using PEDMAS before. So what does this actually mean? Division technically has higher precedence than multiplication in PEDMAS, which means that the divide by 2 is only applied to this lambda divided by p. But I would expect, based on everything we've learned up till now, that this is actually dividing the whole expression. So we're going to change our 1 and 2 to be 4 and 2 to make this math work a little bit better. 4 plus 2 is 6. 4 divided by 2 is 2. 2 times 6 is 12. Divided by 2 should be 6. Let's see how I'm wrong. I am definitely wrong. So once again, he is relying on PEDMAS. So this is actually PEDMAS then. So this is 6 times, wait, what? 4 plus 2 is 6. 4 divided by 2 is 2. 6 times 2 is 12, divided by 2 is 6. But if we do PEDMAS, this is going to be 6 times 2 divided by 2. 2 divided by 2 is 1. 6 times 1 is 6. Wait. I mean, these are probably bad numbers to use. What in God's name? Oh, right. Actually, we got 2 arguments. What am I doing here? What am I doing? 4 and 2 gives us 6. Okay, but we just worked out that each of these actually evaluate to the same. So we need to go to 4 and 4 will be what? 8 times 1. And if we do that all together, it's going to be 4. But if it's 8. So actually, wait. Yeah, PEDMAS doesn't matter here because, I mean, these are distributive or whatever. So we need a different operation here. We need a minus instead. So let's go back to 4 and 2 and just change this to a minus. So this should be 4 plus 2 is 6 times 4 minus, actually let's not do 4 and 2. Let's do 5 and 2. 5 plus 2 is 7 times 5 minus 2 is 3 is 15. And if all of that is divided by 2, we'll get 7.5. But if we have 5, it still doesn't. What we need to change the multiplication then. Have I tried the run button? Yeah. I mean, I'm trying to figure out in my head what I want this to evaluate to though. So we got to change this minus. Actually, let's just, what happens if we do this now? So if we have, and actually let's just copy this. So plus, this becomes minus, this becomes times, divided by 2. So now if we have 4 plus 2 is 6, 4 times 2 is 8, 6 minus 8 is going to be negative 2, divided by 2 is negative 1. But if we have 6 minus 8 divided by 2, that becomes 4. So it's either going to be 2 or negative 1. I think it should be negative 1. Right, we need to get rid of this. It is 3. None of the above. 4 plus 2 is 6. Minus 4 times 2 is 8. 6 minus 8 is negative 2. Negative 2 divided by 2 is negative 1. Where if we have this is 6. Although maybe x is the right argument, and that's why I'm getting this wrong. 6 minus 8 divided by 2. I mean, it shouldn't matter, though, because both of these are... Oh, wait, this is... Minus is no longer a dyad. All right, where's minus? Underscore. There we go. That's our problem, folks. Negative 1 or 3. Negative 1 it is. So, we have determined, after much deliberation, that the minus, which is the second binary operation, which goes here. So yeah, this is incorrect. Dennis should have a set of parentheses here. All right, I'm gonna get a protein bar. You guys, we're gonna go back to Scrabble for a sec. Why do I always put those back on? In case there is no match, it will return none. I think he doesn't because it's multiplication immediately followed by division. Yeah, that's fair enough, but the whole point of this section, so just to clarify what was said in the chat, Sherlock Sage is pointing out that the parentheses can be omitted here due to the fact that multiplication and division, you know, it doesn't really matter. Doesn't affect anything. However, that is true. But the whole point of this section is for us to learn the parsing patterns and combinator patterns here. And so leaving them out completely, like when in one section you relied on PEDMAS, which is confusing because the Jelly language evaluates sort of left to right. And now we're not using that. It's just confusing. Anyways, while I eat my protein bar, back to Scrabble. I'm going to hardware mute my mic just so that you guys don't hear me munching. But let's see who can figure out the best word. I think dashed has been suggested. And we're not going to use the blank here because I don't think that there is a 7-letter word. You always got to save your Hade? I didn't know that was a word. I was just guessing. But we also want to use the U because the U sucks. Look at that up there. Really? Makes me think maybe there is a 7-letter word. Haunted? No, that doesn't take 2 A's. Quashed? With the blank? We need an S, though. We need both a Q and an S for that. We only got one blank. Oh, no, wait, there is an S there. I see what you're saying. I mean, that's good, but the rule of thumb is a blank is worth 35 points. And you basically always want to be bingoing when you have a blank. So we need... I feel like there is a 7-letter word now, and I just don't know it. Yeah, it's hard with 2 A's. Una. Ahead. So like a word that ends in like AUS. Mashed could work. Yeah, once again. Oh, look at that. See? This is the beauty of my little game, is that it shows you the top answers when you find them. So now we know that there's only one word that is more than 54 points, meaning that if there is a bingo, there's only one of them, and there probably isn't. I want to get rid of the U, though. Should we get rid of the U? Or should we just say, forget it? I mean, that's only 18 points, though. Hauled? Where's there an L? There's an L there, but pubs is not a word. Ba-da-da. Oh yeah, we can't do this though because we've got 4 vowels. We need to get rid of more than just one, and we can't get rid of the E if that's the one we're going to get rid of. Huda, Hod. Where the hailed was, I thought, but wouldn't work. I see. I should also order some food at some point. Is it possible to translate this to other languages? Yeah, all you'd need is a dictionary with that's in the language that you want in like text file, and I'm sure you can find those online. Hauled would be a good one actually if there was an L. Lod is a word. Should we just do that? I mean, it's terrible. It's only 10 points. We did it. Hamada. Now we can score a 7-letter word. Herded? That's not a word. Heralded? Threaded? D-headed? D-heads? We want to use all 7 letters though now, so D-heads is not a word? I wonder how it would work for Chinese languages. Yeah, I don't know if you can make this for Chinese. It would have to be like a, you know, what do they call it? Arabic-based alphabet. Something with like letters. Cheated? It's not a word. D. Ha. I mean, we could spell threaded over here, but there's not enough room. Hardened. I mean, I guarantee you that there is a... Also, is there a word that ends in head? I think pinhead is a word. Well, let's... Yeah, there's definitely a 7-letter word here. If number 8 is 60 points... Faded, that's only 6 letters. Theted. What is it? T-H-C-H-S-H. D. Let me look at my keyboard. De-hated, de-haired. De-hailed. De... Headed? I mean, headed is definitely a word, but... Man, can't figure it out. Should we just do hated? Beheaded. That is definitely a word. We need another E or a B, though. That's a good one, though. I mean, technically, you could spell something from down here as well. No, it's almost definitely here. It's an ED at the end. I mean, we could also spell heralded, but once again, EPUB. I mean, EPUBs could be a word in the future, but... Screw it. I give up. We're doing hated. Hated is still really good. Here we go, though. Redhead. I said it was something head, remember? And bedhead. Very sad. Redhead, bedhead, even deadhead is a word. Adhered. That's a good one. And de-ashed. I wouldn't have gotten that one. But still pretty good. I mean, 60 points for a non-bingo. All right, we'll do... we're down by 50 points, though. Not good. Let's see. Can we do it this time, though? Now we've got 3 vowels. Can serve. Careens? That's a word, right? Hey, whoa, look at that. There's a bingo. And then there's 11 bingos better than that. So, I mean, where can we put... Is there other places we can put careens? My guess is... Or I guess careened? That doesn't even make the top 14. Cleaner. That's the 4th best. And might be spellable here too. Poor is not a word. Should we just do cleaner? Cleaner's good enough. Arch enemy. Wow. 9-letter bingo. That's pretty phenomenal. Reclean, menacer, recanes, careens, recaned, recanes. All right. Back to, we've had our protein bar. We've got some caffeine in us. Careens with the S below the X. Oh, EXS is not a word, unfortunately. It's EXES. Yeah. So. We left off having determined that Dennis has left out a set of parentheses here. And we have E, eta. But what's really interesting is that when you combine eta with a three-dyad leading chain, a leading three-dyad chain, then you end up with the dyadic fork, which is an observation. I mean, my thoughts right now are that this is just like overwhelmingly confusing. You've got two tables of pattern matching, special cases of LCCs, your current value, one argument or two arguments, and then based on the interaction of all this stuff, you end up with some sort of parsing. And at the moment, it doesn't really seem like, even within the pattern matching things, you've got like, only if your nilad is a constant, not like some other type of nilad. So, it is what it is. And I'm not really sure, do we go and fill this out and say that, this is E, and that this is, what was eta? I guess we'll do lowercase eta. Ooh. It does not like showing an eta. What if we get eta from somewhere else? Eta. Greek. What about that? No. All right, well. JetBrains Mono does not. Does not. So what are the other capital eta is just H? I mean, we can't use that. I don't really want to use epsilon. But maybe we will. Epsilon almost surely. But the thing is you can... If a chain starts with three dyads, so they call a LCC, what was an LCC again? It was a leading constant chain. So, I mean, why don't we call, like, if we're going to name this one, how come we're not naming this one? An LDC, a leading dyadic chain. A certain part of the chain has to consist of a nilad followed by a list of monads or dyad, nilad, nilad, dyad pairs. In other words, the arities of the chain segment had to match the regex expression. And then we've got these, three different ways to start a dyadic chain. We're going to call this one the LDC, the leading dyadic chain, an LCC. And if none of the above, then this. It's just like goodness gracious. All right, what are we doing here? We're losing momentum. Let's just move on. I feel let's not move on. You know, chain patterns. Let's just put at the top here. You know, what are we calling this? What do they call it? LCCs, leading constant chain. We're just going to call this special chains. Special chain names. And we've got LCC equals leading constant chain. Actually, we're just doing this. I'm not going to explain it. Then we've got LDC. Oops. Leading dyadic chain. You know, described in the first bullet here. And sure. So then we're gonna, you know, and like the irony that in the monadic chain section you can dyadically or monadically call something. You know? Why is it a monadic chain if it can be called dyadically? You know? I mean, does that even make sense? Yeah, like what? I'm going crazy here. Yeah, Tobias, why am I doing this to myself? And I'm flexing my combinator brain. I mean, let's actually like take a step back here for a sec. We've got this chain section with subsections, niladic, monadic, dyadic. And in the monadic chain section, the example that is given is called dyadically. Actually, it's not. It's called monadically. But it starts off with the dyadic function. So I guess that's what's implicit here. I mean, is it implicit? Monadic chains are broken down from left to right. Also, we're past some omega here. So that this is that's very important. You know, define. Or actually, you know, what makes my chain monadic? Actually, I don't know how to do this. We'll just make it a Q. And the answer is, if you only pass it one argument, which is referred to as omega, aka omega. And it's completely fine to use dyadic functions inside your monadic chains, because Jelly has this property where it will just implicitly duplicate your argument to make your dyadic function a monadic function, at least at the start. Later on, when you have V will be used as the left argument, and omega will be used as the right argument. Oh boy. I mean, I'm sure there's some genius to this at the end of the day, you know? And we'll copy this. Q. What makes my chain dyadic? If you pass it two arguments, aka lambda and rho. Where'd it go? Where'd it go? And so what does that mean? What does that mean? What that means is that you can't just refer to a 2-0 chain, because there are two types of 2-0 chains. Is there? There is. I mean, there is not. This is identical. Because once you see, that is what's confusing here, folks. I mean, there's a lot of things that are confusing, but that's what's confusing. One of the things that's confusing is that if you actually look, the last actually, what the hell? Dennis, my guy. The only row that's different in this monadic table is the first one. Everything else is identical. This is identical. The last four rows of the dyadic chain table is identical to the last four rows of the monadic chain table. Which is a very important observation, because in my head, what I'm trying to do is to, you know, is to build up this like combinator table, so that, you know, I could potentially go and add Jelly. I mean, if anything, I should add J here. What's Remy saying? Remy's saying you probably need to just run it in the REPL to get some intuition. So all dyads become beside. Yeah, I mean, I completely agree that I just need to start messing around. But the thing is like, I don't like messing around. This interface is terrible. No offense to Dennis, but like, one, in order to type things, I have to go to this first tab. And like, I assume that because Dennis, you know, has an international keyboard and knows how to type stuff, he doesn't need to click around. But like, one, I don't even know what these things do, so I gotta hover over them. And you can do this search thing. You can do a range search, and then it filters down. But like, then still, I've got to like hover over each of these and find the one that I want. And then, you know, I technically could go type the R in here if I wanted, but I could just click it. And then once I've done that, that's now I'm on. Remember, I'm on the first tab here. I cannot execute my expression here. This is just for typing it. Then I have to go to the second one where my expression is, type in X and Y, and then hit run. So I have to toggle, and it's not even tabs, right? I can't like Alt tab, or I can't, control up and down. I have to use my mouse manually to click between these two different things. One for quote unquote typing, one for evaluating. And on top of that, like I don't actually know how to type this stuff, all other editors, they have the same problems. BQN, APLJ, you need to figure, I guess J doesn't. You have to figure out how to input this stuff. But the point being is that, if we come back to this, tool that we haven't actually, touched in a while because we've just been trying to learn, like I can very quickly, like, now, like, I don't have to remember that R underdot is reverse. I can just type reverse, iota 5, and then I can go iota reverse 5, and like I can now, I'm flying. Because I don't need to worry about switching between tabs. I don't need to worry about searching for things. I can forget, if I want, I can kind of slowly start to learn this stuff. But really, like what I care about is these chaining ideas, which admittedly, I got to be honest, I'm starting to think that like I was much more excited 3 hours and 52 minutes ago when this stream started about the potential significance of like the combinator ideas in here. After 3 hours and 52 minutes, I'm pretty certain that there is still some cool stuff going on, but it's not anything that's like mind-blowingly revolutionary. He has a very, very complicated set of rules for forming these patterns. Not what I expected. What was the chat saying? Jelly is not Dennis's page. I did not know that. It's from Adam. Adam made Jelly? I did not realize that. Well, I'll have to talk to Adam. Good work then, Dennis. Well, I mean, still, you missed out some parentheses here and there, but still, people make this own. The level of documentation is still pretty good. We're making our way through it. There's no way you'll be able to use all the keys. You'll just have to find enough moed diodes to try the syntax. Oh, yeah. Sherlock's just saying the same thing, that this Jelly site has... Oh, so that actually makes sense. I mean, I said at the beginning of the stream that it's interesting that this site does not link to this Jelly interpreter. Alrighty. Anyway, so I kind of, ramble done. I want to be able to build this combinator table that, is similar to what my website is. And spelling. And, if we put S here, we come and copy B1. We've got E. We've got epsilon. And so, what is the spelling of this? This is a 2-1 monadic chain. B1 is a Wait, what? I'm so confused at the moment. We call it a 2-1 chain. The interpreter has specific rules for breaking down chains based on their arities. Those rules dictate that given a single argument n, so this is wrong then. This 2-1 chain could be called dyadically. Well, where the hell does it show up in this table then? Dyadically, it's B1. So wait, is this a plus H is a 2-1 chain? But how is that parsed dyadically? If your chain starts with 3 dyads, it does not. Otherwise, if the chain is an LCC, so it's not an LDC, it's not an LCC, otherwise we start from V equal to lambda, which is our left argument. So in our case, we'll just say it's 10 and 20. 10 is lambda. And then we have a single binary function. So V becomes 10, rho. So like that's, you know, the absurdity of the mental, like maybe there's an easier way to teach this, but like you basically, so it's I just think that like these tables are maybe it is the best. I don't know. I have to think about it a bit more. But basically this is wrong. This is wrong. This B1 here. So what we're going to call this LDC, LCC, and what do you call? What do we call the? We'll call it JL for just left. Leading constant chain, leading dyadic chain. Because like we need to name this stuff, you know. Just used left arg as V. So yeah, 2-1. So I'm pretty sure we can delete this. I mean, we'll leave this here for a sec, but and so then is 2-1 always monadic? Let's catch up on the chat here. Which is just a way to type jelly. Lots of shortcuts. Oh my lord. I don't know what oh my lord was for. If I scroll down to the bottom of the multi-chain links, there's the to-do example. Oh. We're getting to the bottom of this. I mean, slowly but surely, I am making sense of this. The question is, so like, let me just rewind like the mental arithmetic though that happened. So like, if we scroll up back to this example, we've got our, you know, and actually let's you know, let's have our example section. Examples, you know, the first one that's covered here. So this is this can be called monadically or dyadically. If called monadically, it's a 2-1 monadic train, aka the S combinator. If called dyadically, it is a you know, JL plus, and I guess we need, we're missing this. Let me just go borrow that from here. Pretty close. It's a JL plus you know, like what is it actually? It's a JL plus 5 plus 6 from this table. You know, which ends up being the B1 combinator. And that's just brutal. Then we can come back to our other examples. So this was our first monadic one. And so here's the thing is I bet let's do this. We're gonna parse this first, you know. And then this is where I bet this is the thing. So in the example, it's shown monadically. But I bet it's something more than that. So, you know, in this case, we're going to end up with, you know, S it's like S plus sigma, you know? Are dyads and monads overloaded? No. The symbols and letters that define the functions in Jelly are not overloaded. There's no ambivalence. However, every program that you can write can be called either monadic or dyadically. So really, this is your S combinator, which forms a unary function. And then once again, you're applying that unary function to your initial argument omega. And then this is the sigma combinator, which is just so, you know, let's go get a sigma. Oh, I don't have sigma here. Oops. Maybe I should update my website to include a sigma and delta. Sigma, so it's S that forms a monadic function that is then used in sigma, which is the analog of S. So whereas S applies a unary function to the right argument, sigma applies a unary function to the left argument. Oh my goodness. I haven't had to flex my brain this hard in a while. So, yeah, I think it is correct to say this. Yeah, so if called monadically, S forms a monadic function that is used in sigma. So, and this is what the okay, if I'm correct about whatever I'm about to say, we've made some serious progress in understanding this absolutely convoluted. I don't even necessarily think it's the language. I think the pedagogical value of this README might be very low, which is why we're having such a hard time. We're over 4 hours in, and we're still working on it. But so it describes this function and evaluates it monadically because we're in the monadic chain section. However, we could just assume that it is a dyadic function. So we've got a dyadic function. So this would be a 2-1-2 chain. So actually, and let's call this, and is a 2-1-2 chain. This would be a 2-1-2 chain. And so it's not going to be an LDD or an LDC, a leading dyadic chain. It's not going to be an LDC. It's not going to be an LCC. So that means we're going to evaluate it with a just left, which means we assign our V to be the first value. So let's assume we've got 1 and 2. So V is going to be 1, and that means we're gonna pattern match on this stuff, right? So we've got 2-1-2. So basically, we're always going to be hitting the last two cases. 1 plus 2 is going to be 3. Squaring is going to be 9, and then this is going to be the tricky part. Times is going to be times with what? So wait, what's the, when you end up with it's with row. And row was our initial argument of 2. So it's going to be 18. All right. Listen, folks, if I get this right, I've entered, I was about to say jelly god mode, but not really. Probably just like, demigod. I wouldn't, we'll go, son of a god or something like that, Hercules or whatever. So we've got 1, we've got 2, we switch to this tab, we hit run, and we expect 18, folks. Look at that. All right. So what does that mean? What's your combinator list again? It's here. Yeah, I didn't link it. I didn't realize we were going to be relying on it so much. I probably should have put it in the description. B1 is a unary function evaluated after a binary function. I think Jelly's main contribution to trains isn't a new way of thinking about trains. It's that seems to do the best at compacting all train types into as small space as it can. Great for golfing. I mean, I think there still might be something here, You end up with this, you end up with this. So right, so let's if called dyadically, so this ends up being what? This ends up being a plus b to the power of 2 times b. So in APL speak, that's ab square, and then this is just the B1 combinator, and then you would do a fork. You would do times with the fork. So it doesn't really form anything. It just forms a mess. So yeah, the 2-1 is the B1 combinator. And then after that, you know, multiply, or I guess we should go get the times. Doesn't really correspond to anything. I mean, you can spell it in APL, but it makes use of identity. I mean, maybe it's the E. Actually, is it S? Or no, D? I mean, it's not here, actually, to be totally honest. It would be A, E, C, D, E. So it's the eagle where the B combinator, or sorry, the B argument is the same as the E argument, which actually is interesting because that's exactly how it's spelt, right? This is going to end up being like, so actually let's just spell this instead of me, you know, running around in circles here. Whoa, where's I don't have ride on my computer anymore, or for some reason. All right, we'll just do this in try APL. Didn't type enough there. Try APL. So we've got 1, we've got 2. The first thing we do is we add them together. The second thing we do, and actually to make this simpler, we're going to call square is power. So now if we put this together, this is going to form the B1 combinator. We're applying square after adding them together. Now, in order to do the multiplication with the initial thing, we put multiplication in here, and then we add the identity, which is going to retrieve the right argument. So this is basically a phi1 combinator, a dyadic fork, but it could be specialized due to the fact that we're not actually doing an operation other than technically this is kappa or ki in combinatory logic. And it's upset. Why? Right, because we need to put this in parentheses in order for it to parse correctly, and then we get our 18. So, I mean, this is basically what I just wrote out right here, right? You can see this is that, and I forgot a set of parentheses, but it's basically exactly what I just wrote. So this is, you know, B1 combinator that is then used in phi1 combinator. But that's just because we need phi now too. Phi now where the right dyadic function, or it's actually the left dyadic function, is, you know, let's just use the tack instead of having to say, you know, all right, well, all right, we got one more example to do. You know, it's all starting to come together. How many people are absolutely just totally lost? Don't blame you. So here's the thing, though, is can a dyadic chain be called monadically? So we've got plus times divides have. Let's just off the bat, my guess is that this is going to say not enough arguments. Nope, was totally wrong. You know why? That's right. Because it duplicates. It duplicates, folks. So, and actually, let's example 1 from section 3 is the one. It's actually section 4.2. Section 4.2, and this is going to be example 3 from section 4.3, I'm assuming. 4.3. So, can be called monadically, and in this case, it walks us through. Whoops. And it is a. So this is, and it is a. This is going to be a 2, 2, 2, 1 chain. Does this look terrible? That's all right. Ends up being. So you know, it applies W. So in our case, what we just looked at with 1, that's going to be 1 plus 1 gives us 2, and that's going to be V. And then every single one of these, oh, actually, no, wait, did we have a 2-2 chain? We did have a 2-2 chain, didn't we? A 2-2 chain. So now we've got V, and we've got lambda and rho. Except we don't have lambda and rho. All we have is rho. So wait, let's just do this step by step. This is going to give us 2 for sure, right? There we go. What do people think? Well, this is going to give us just plus p. So this is going to give us, no, times. So I mean, it's just going to return us 2 again, as expected. But if we change this to 2, it's going to be 2 plus 2 times 2, which is going to be 4 times 2 is 8. Correct. All right. Now, this is where things get interesting, though. So we're no longer going to hit rule 5. We're going to hit rule 2, which is asking us for lambda and rho, but we only have one of them. So my guess is that the quote-unquote duplication of our single argument means that both lambda and rho are the same value, in which case it's going to be 2, 4. So actually, we need a different number now. So if it was going to be 1, it's going to be 1 plus 1 is 2 times 1 divided by 1, which is just 2. Maha. However, if we do 3, 3 plus 3 is 9. Or sorry, 3 plus 3 is 6. I mean, whenever this is division, basically times divides. It's just a no-op, so it's just going to be doubling a number. Yeah. So, but let's what is a good operation, a binary operation? Do they have a modulus? No, a modulus with itself. We've got plus, we've got minus gives you 0. So this is always just going to return you not 0. 3 plus 3 is 6. 3 minus 3 should be 0. Why does that not work? Why does that not work? I mean, right, when we're in Oh, right, because once again, it's negation. This is subtraction. What the F? Subtraction. This gives me 0 at least. So 3 plus 3 is 6. 6 times 3 is 18. And minus 3. Wow, 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 wow. Wow, 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 wow. Oh, shit. Huh. Right. So my mistake is that when it's called monadically, we're not using this table anymore. So 2, 2, 2 chain, 2, 2, 2, 1 chain is just going to end up here. Although actually, so it becomes 1 plus 1, or what's my argument here? I'm using 3. 3 plus 3 is 6 times 3 is 18 minus 3. But then, so yeah, if we do h, is h half? Right. So it didn't go from 15 to 7.5 because now we're hitting a 2-1 chain, which has the pattern of applying the binary operation after applying the unary operation, aka the S combinator, aka you're dividing 3 by 2 because you're halving, and then you end up with 18 minus 1.5, which is equal to 16.5, which is exactly what I thought. Oh. All right. Sure, great, we win. If called monadically, W is applied, then we evaluate the two part as kind of like repetitive S combinators, really. Yeah. As repeated S, I mean, that's not really the way it's parsing. As repeated S combinators. And then the, 2, 1. It's actually not, it's, or 2 S combinators. And then the 2, 1 chain at the end matches the S combinator. If called dyadically, we have LDC, which means the 222 forms the phi 1 combinator, and then that sits inside a B1 combinator as, which yields a binary function that is then used in the B1 combinator along with the final monadic operation. Oh my goodness. Well, I think I kind of get it at least. To summarize what we've learned so far, you form expressions, and depending on whether you invoke that expression monadically or dyadically, you go to one of two tables. And for the dyadic case, you got to do some upfront checking. Do you have an LLC or an LDC, or the else case? Whereas in the monadic case, zero or more monads. Yeah, so I think confusingly, I think this is just the LCC, right? Sometimes for certain parsing, yeah, I could be wrong, but I'm pretty sure this corresponds to the LCC. So in the monadic case, you only need to consider LCCs and the else case. In the dyadic case, you have to consider LLCs, LDCs, and the else case. Once you do those considerations, you just go to the table, you pattern match, and you evaluate based on that. And in the case where you have binary functions, you're constantly referring, like you have dyadic functions inside of a monadic chain that was monadic because it was called monadically. Whenever you have a dyadic function, you're constantly duplicating your initial argument. Whereas in the case of the dyadic chains, there's a couple different ones where you'll be referring back to your initial arguments, which ends up creating this kind of like nested fork and nested S combinator behavior, which makes sense because it's based on J, right? So J used the hook, aka the S combinator, as their 2 train, and forks as their 3 trains. So it makes sense that you've got these kind of nested S combinators and phi combinators. And then you're done. I mean, we're not done. We're going to do multi-chain links. Yeah. I think Yeah, there's definitely a better way to teach this stuff. I think really you should have some kind of like. I mean, I am interested though to. I mean, is the. Oh, there is a pull request. Add all plain monads. Jeez Louise. Should we add these? I think that, you know, if we stay in monad land though for now, I mean monadic chain land for now, which still can involve dyadic functions. Yeah, let's just ship it. Signees. Labels. And we might go change some of those names later, but let's kill this. Pull. And you know what we need? We need some way to do like the autocomplete, because now I don't know all the names. I wonder if we can just feed our script. Probably not, but let's give it a shot. Let's go to ChatGPT, start a new one. Hello. I have a Python script that is a simple REPL. What happened? There I was saying you can use a to get rid of the if statement. Oh, here? Is it? Well, what is it going to do if it's not there? Does it just return you none? We can do that. We can do that in a sec. You can type any of the keys. What is this dictionary called? In jelly tokens. And it will in the REPL. It would be nice if while typing you could get auto complete of these keys. Are you able to modify my script so that it does that? If this works, folks, holy smokes. Because I have absolutely no idea how you would do this. To implement autocomplete functionality, you can use the prompt toolkit. Sure. Now you can modify the script. Bruh, can you just... well, I guess we'll do this. I would have asked it, but... so... if this works. Whew! I'm excited. I don't actually think it's going to work, but there's a small chance it does. All right, here we go. Iota? Maybe it's because we're doing RL wrap. Well, it definitely just does not work. Let's give it the whole error. Why not? Following error. Sure. Seems like a dependency issue. Oh, whoops. Holy shit. Oh my God. Are you kidding me? Wow. We're taking a short break, folks. All right, we're back. Small washroom break. Holy smokes. Can you believe that? Except now, it doesn't look like... my up and arrow keys are gone. Whoop. Iota, reverse, odd, sumvec 10. Wow. So, I mean, there's a small issue now that... well, actually, let's just ask. Seeing as ChatGPT is ruler of all. This is amazing. You are our future overlord. Thank you for your help. One small problem. I use this script with rlwrap, but now it seems the up and arrow keys do not work. Probably because of the fact that we're using that word completer. Is there a way to fix this? To make sure it works well with your script, you might need to adjust the prompt used by Prompt Toolkit to use a simpler one that works better with rlwrap. Okay. I don't want to have to copy and paste. Can you just fill in the jelly tokens dict as well? Tired of doing this. No. Ugh. Yeah, so I think it's just this single line change here. Right, so iota rev sum. That didn't work. Okay, let's just go. I can do this for another umpteenth time. I mean, technically, we can just leave this up here for the moment. Or can we? I don't know that we actually can. Yeah, because we need... Of course, that wasn't the right place. No. Shit. I meant that the arrow keys still don't work. Well, Jesus, now we just confused it. Okay, let's start anew. We confused it. Sorry, ChatGPT. And actually, let's just go back to... Let's go back to this. Make sure that this works. So yeah, let's go back here. And I have a script that, what does it use? Word completer from prompt toolkit. That uses word completer. It works great, but the RL wrap up and down arrow keys no longer. Although, I wonder if there's just a way to write yeah, probably not. Probably not. You probably need RL wrap. Is there a solution for both and RL wrap to work? Or maybe prompt kit can be used for instead of RL wrap for history and jumping around with the control keys. That seems like what I want. Whew! Folks. Oh my goodness. It's so beautiful. Oh my god. We should rename this live stream to ChatGPT demystifies So what could we do? We do odd. We do index. Ooh. Right. And we need to clean that up a little bit. Whoop. Right, it's some list. It's actually a good question. Why is it called some list and some vec? Oh, some vect. Huh. Sorry, I just stopped tapping on the mic. Well, let's commit this. This is pretty phenomenal. I guess we need to touch. And it's called nope, not what I wanted. Right. Let's see. Dictionary key literal factorial repeated. Isn't roughed amazing, folks? All right. And honestly, we should put these in a separate file. That would have saved us all that copying hassle. We'll do that in a sec, though. Add auto. I don't know why I put an underscore there. Add autocomplete. Thanks, Chat GPT. Yeah, let's do that now. Chat. Tokens.py. Is that what we want to call it? No, we want to actually that's fine. And we will call these phonetic. Tokens dot import tokens. Will it work? Ah, it still works. My guess is I upset rough, though. Which I did. We need cycle move tokens to its own file. All right. I mean, I wonder if actually we should put the 10 at the end, or at the beginning. Seeing as we're evaluating it left to right, you know what I mean? Maybe not. Okay, well. Let's go back to this tutorial. Actually, I mean my my markdown file is now better. So let's just stick with that for a moment. And actually, let's just put a work in progress on this section. Also, right. Q for exit. Update readme with jelly chain info. All right, let's go now back to What happened with that link? Whoops. Interesting. All right, so what I want to do next is we're going to start building I think this is where it's going to really get interesting. So, you know, iota, reverse, odd, index 10. We're gonna add some info here that basically first thing we're gonna do is we're gonna add info that says what kind of chain it is. This is a 1-1-1-1-1 chain. 1-1-1-1 chain. 4 ones, 1-1-1-1 chain. That's gonna be easy. And we're going to do that by we can just check, right? Expr. Chain type equals and def. What do we call this? Arity? I mean, what do we we're calling, what is the terminology we should use here? Atoms. So there are atoms, and then what do we call? So the atoms. All right, but what's the name that we should call? The name of it. Keyword? Keyword in atoms. So we want keyword arity. This should consist of keywords. This will consist of jelly atoms. This is our argument. So key, this would be a string, and this is going to be an int. And we're basically currently we're going to assert that k is in tokens.monadic, and then just return 1. And we will update this with our dyadic ones in a sec. So we're going to go hyphen join of keyword arity of w for w in expr. Should do e. And then technically, I think this needs to be a string. There's actually probably a nicer way to do this with f strings, but not important for now. And so then we just go cprint and we go print. This is a cprint 4.red see if that works. Okay. Right. Man, I swear I have messed up. I mean, so that's our first little piece of info there. Did I not save this? I don't want that anymore. So the question is, yeah, we need to fix that though too. Let's go fix this. This should be just combinator, and we should get rid of that. Actually, just call it memo. We need rough first. Actually, add. Whoops. So yeah, we're going to stay in monadic chain land. And we're going to stay in nilad land, constant nilad land, where all nilads are basically just constants. And then we're going to start to add binary functions, dyadic functions. All right, I'm back. Sorry, I was messaging someone. And I just saw some people commenting in the chat. We're still going. Of course we're still going. I said this could be a 10-hour stream. And honestly, we've made, for folks that maybe left for a while, I mean, it's amazing. ChatGPT added autocomplete for us. Thanks, ChatGPT. Friggin' fantastic. And it also fixed our need for RL wrap, which got broken a tiny bit. So all of the work that actually don't. What was their username? They were in the chat earlier. They might have disappeared though. EVL Robinson, Evan Lewis Robinson. Doesn't say where they're from, but they went and added all of the monadic operations, which is fantastic because I don't need to do that, but not great because now I don't know what they are, which is why autocomplete is absolutely fantastic. And yeah, we're doing fantastic. I think I, for the most part, understand how the chains work. We'll maybe do multi-chains in a different stream. But what I'm in the midst of doing now is adding chain information. And basically I want, because it has become clear that when you have a chain, the implicit combinators that end up getting formed is dependent on the chain, obviously. But it's not just as simple as kind of saying, you know, the S combinator is the 2-1 monadic chain. You can have a bunch of S combinators all over the place, and it doesn't necessarily follow that like a 2-1 chain follows it. Like you could have some other, you know, juxtaposition of functions that form a chain where in the midst of it you have an S combinator. Oh, Sherlock Sage in the comments is the individual. So thank you to Evan or Sherlock. I'm not sure how we should refer to you going forward. Updating on the chat. Hope the names are okay. Yeah, if there's any issues with them, we can just change them. It's all good. Some list is over a flat list. Some vect is over vectorized. There's a few of those commands that are different over kinds of arrays. Also, how should we deal with the prefixed monads? We haven't gotten to those yet. We'll get to those. Terrence saying, I can't believe this is still going. Oh, actually, I just remembered. One of the things Dennis was planning before his hiatus was to actually change Jelly to keywords instead of this code page we're working with now. So it's nice that that's finally happening. I had no idea that was his plan, and if I had known that, then maybe I wouldn't be doing this right now. We have all the 1-character monads now, but we still have the 2-character monads to add. Yeah, it's all right. We can add those later. What I want for the moment is just a couple of the dyads. So maybe let's just go add these ones. Is this modulus? Bitwise OR. All right, well, let's just go add these ones. And what's negate? Minus is a negative number. Okay, well, let's just go add these. And the question is, so we're going to call these dyadic. And I mean, I think pretty obvious we should just leave some of these the same. I mean, what is slash? Where is slash? Over here. Quick. Reduce or n-wise reduce? So we'll just call it div. That was his plan back in 2016, and he hasn't come back to it. That's too bad. Whoa. We'll use star. I mean, what is star though? I'm assuming star is in here as well. Yeah, what is star here? Exponential. No, we're using star for multiplication. And we're going to use, I mean, should we actually, maybe we should just use slash and then call it fold. Whatever, we can change our minds, right? This doesn't really matter. Except I messed this up. So actually, yeah, what are we doing for subtraction? Should we just do the underbar minus? I don't mind that. Then we come back here. So if and now what we want to do is convert our convert to jelly. Tokens is entire tokens dyadic. And then if token dot numeric is number is numeric, return string of, actually wait, we just return token. Right? So let's make this thing blow up. So, I mean, the example was plus half. I mean, so the 2-1 chain thing works. How? And actually, let's, we're only dealing with monadic chains right now. But, to do, update this when we allow dyadic chains. I mean, I was kind of surprised that worked, but that's right. We're just passing it along to the jelly interpreter, and it knows how to deal with this. So I mean, 2-1. So what if we do plus half again? So this is a 2-1, 2-1 chain. It's going to evaluate 2-1 is a 2-1 chain. The first 2-1 is a 2-1 chain. And that's what gives us our 15. We're doubling, then halving. Then a plus h plus is just going to add your initial argument back to your result of 15, which is 25. But when you get a 2-1, 2-1 chain, you've then changed the behavior. So now you're doing a 2-1 chain again. Which is, actually, why does that work? I mean, so, and actually you almost want this for every single one, right? Because a 2, 1, 2, that's going to be 15 plus 10. But a 2, 1, so actually let's go back to our table here. Once you've evaluated a 2, 1 chain, you have a V now. And so a 2, 1 chain is going to be the S combinator once again, right? So actually, I messed that up. It's 10 plus 5. Not 20 plus 10 divided by 2, which gives you 15. So then this 2, 1, 2 chain is just going to be 10 plus 15. This 2, 1, 2, 1 chain is going to be 15 plus half of 10, which is going to be 20. Ooh, this is so freaking cool. I mean, now that we're actually making progress. I still think this is hella confusing. But, so really, the way that this ends up parsing is that we end up with an S Oh my god, this is next level stuff. So what I'm thinking is that at the beginning of a link or chain, whatever these things are called, this is the W combinator, this is the S combinator, this is the S combinator, which forms a unary function that becomes the unary function inside a sigma combinator. And then, so this is basically WS, S plus sigma, and then this is S which forms a unary function. That's so cool. Inside of a phi combinator. So this is W, this is S plus sigma, and this is S plus phi. Wow. So the question is there like an algebra where you can deterministically just kind of pop this stuff out instead of having to hand roll this? And I think there is. So a 2-1 chain, not at the beginning of a monadic chain, is always going to be a phi combinator. And a 2-1 chain at the beginning of a monadic chain is going to be the S combinator. Binary function by itself will be W. A binary function at the beginning. So basically, you've got. Oh, we're making real progress now, folks. So yeah, this is really combinator. So we got rid of at one point. Strap in, folks. I mean, there's actually I think it's been consistently the same number of people watching throughout. There's just been less chatter. Message in the chat if you're actually watching, regardless of whether you're confused or not. So combinator, starting combinator, and non-starting combinator. What do we call it? Initial combinator. Following? Sequential? What do we call this? Follow up? Sequential? No. Succeeding? Proceeding? Succeeding? Initial and succeeding. So IC equals initial combinator, SC equals and so a succeeding 2-1 chain is phi. Let's go. Where'd phi go? Come on, come back, phi. We had you at some point. Oh, that was in the it's in the example section, is it not? So there are a few people still here. All right. So then, and then once again, yeah, a binary at the beginning of a monadic chain is the W. But in the middle of a chain, because you're going to have V, which is basically the application of a unary function to that, it's going to be sigma. So let's go get sigma. This is the demystification. This is, what are we at? 5.5 hours. Only took 5.5 hours, and we are finally demystifying this stuff. F always is just going to be, F is nothing. F is just a unary function application. The dyad, nilad, both of the times, it's unclear actually. We'll get to that, but really the important ones are number 1, our 2-1 chain, and our 2 chain. And so now what we can do, now that we have this, we can build up a visual breakdown. So basically what I want, where's my snipping tool? What's going on here? Actually, there's a shortcut for this, is there not? Yeah, perfect. Take this, copy, JS Paint Online. Would you like? Yes. All right, I was just making sure that's going to do the right thing. So what I want is the following. I want this as S, and then this as sigma? Oh, except it's not though. It's not. It's phi. Oh, yes. And that's oh, it's so brilliant. It's so brilliant. Because, oh my God. Yeah, that's exactly what I want. That's what we're going to build, folks. It's not even going to be that hard. Wow. I mean, we're definitely doing this. I'm getting a little tired. I have barely had anything to eat today. I got to order some food in a sec. But we're going to do this until it's done. It's only 5:30 p.m. here. I understand some of you got to go to sleep. And that's the thing. Oh, and so let's go back for a sec. If we get rid of this half now, and we only have a 2-1-2 chain, so let's do the snippy tool thing again. Where's a screenshot? So now if we grab this, can I paste it here as well? Yeah, let's just do this over here. So same thing here. But now what happens is that this is S, and now because you've got this pattern with a 2, this becomes sigma, where, wow, that is very cool. Because really what happens here is this 2-1-2 chain turns into a 1-2 chain, which isn't talked about anywhere in the tables. But the implicit combination of the fact that this creates a unary function. This 2-1 chain creates a unary function, even though you're evaluating it, whatever. You then, when you have a 1-2 chain, this becomes sigma. And that's dope. All right, we know what we're doing now. And also, too, just for just for clarity, the 2-1 chain. Should we do this with red? 2, 1. Oh, come on, that's not what we want. Anyways, we'll just write it out ugly. So we've got 2, 1, and then we've got 2. So for these, we'll go back to white. This is just going to be, whoops. This is just going to be S, and this is just going to be W. The question is, how will I print the AST in Python? We'll ask ChatGPT. But basically, try-APL has a thing where you do this, poof, it prints it for you. And this one's a little bit trickier because you've actually got to go ahead. You have to do you do have to do a look-ahead thing, right? Because you need to know the width of these things in order for how many of these you need. Whereas here, we're upside down. So I can just build this step by step, and I just need to keep track of what's on the previous line. And there's a couple different ways we can display this, but like you're doing it because you're doing it the reverse of the way APL is doing it. It's just line by line, and then you're progressively going to build things out to the left. And like you know that the endpoint of each of these is just going to be like wherever you're at in the expression. It's actually like honestly, the trickiest part is just going to be getting these symbols and printing them out. But like I don't think that's going to be that hard. Like there's like Unicode symbols that you can use to print this stuff out. I don't guarantee anything, but I think hour and a half tops, we can get it working. And then we're gonna get the sigma and S. This is turning out even cooler than I thought. And keep in mind, 2 hours ago I was pulling my hair out because this wasn't making a lot of sense. So where do we start? This is very exciting. First, how is if it's quit? Right. We need to go fix that right now. Actually, first thing we were gonna do though. Yeah, git status, git diff. That's right. We've added the dyadic ones. And I think that kind of works. So wait, let's just commit this stuff. First, we need to rough. That's not really updates. Small fixes. Right, that's fine. Add shell dyadic functions, and then we need a small fix for Perfect. Is it bug? Oops. Yeah, it is bug. All right, I need another bubbly. I'll be back 2 seconds. All right. And then once we get this working, I'm probably going to call it. I mean, if we get this working in an hour, maybe I'll keep going because I'll be so excited. But back to ChatGPT. What are the Unicode characters you can use to... How many have gone through? I don't know. I think like 4 or 5 at this point. I did have a Coke Zero at one point for the caffeine, though. To display tree-like diagrams. Sort of like these. Can you show me more box ones? That is... I need this and I need this. I wonder if actually, if there's like a Python library already that does this. Maybe we're getting way too far ahead of yourself. Well, first of all, we'll go copy and paste this just so we have it. And actually, let's create a new file. Touch, box diagrams, boxes, box UI, box display. Don't need these. Actually, do we need? Maybe need those. Probably don't need those. And then all we need. That's all we need. Let's go back to ChatGPT. Is there a library, Python library for constructing tree diagrams to box tree diagrams with these actually let's get the specific ones we want. All we want is, I think we just want these ones and we want this one. Potentially, we don't even want, this is all we want, I think. Is there a Python library for constructing a tree with these characters? I mean, they misunderstood drastically what I wanted. That being said, we are going to go run this and see what happens. What's the next YouTube video? I mean, I actually had 2 or 3 on my list. One of them was going to be my favorite languages. The other one was going to be the state of array languages. Meaning, like, what are the, with WeWa, J, APL, BQM, CAP, NARS 2000, all the open source ones, basically. I guess Dialog APL is not open source, but like all the usable ones, what's the state of array languages, but not what, when. I don't know. Next week, couple weeks. Technically, this counts as a very, very long YouTube video. Kind of. So let's comment this stuff out. And yeah, Python 3 box display. Oh. Yeah. Lol, this is what it created. Not exactly what we wanted. ASCII network. So let's try this one. Whoa. pip3 install ASCII net. Oi, look at all the stuff it's downloading. Cannot import name network from ASCII net. What happened? Lol. All right, well, it doesn't seem like why is it that most of my favorite creators have a horrible work rate? What does work rate mean? Just like the cadence at which we release videos? All right, let's hand roll this. Yes. Well, in my defense, I released like 300 videos in like 3 years at one point. I was releasing a video like once every 3 days. But then I got a job in Silicon Valley and was focusing on that. Now I just make videos when I feel like it. And, depends on what's going on in my life. And, yeah, it's more of kind of like I do it because it makes me happy. And, whenever I see other YouTubers and they're like, oh, I need to take a break. And I'm just like, just take a break then. I don't technically, I give all of this stuff away for free. And I do enjoy, people when they get excited about the videos and stuff. But, yeah, I mean, I did say, I'm not sure if you were here for the beginning of the stream. I enjoy podcasts just as much as I enjoy YouTube videos, potentially even more. And so even though I haven't been regularly releasing YouTube videos, I, for 156 weeks straight, aka 3 years, have not missed a week of uploading this. And it's slightly different content, but still, in the same area. And also there's a raycast. And I did mention when I mentioned these at the top that I've thought about uploading the podcasts as YouTube videos because I think some people just prefer YouTube videos. But I don't know. I don't know how many people would actually prefer that. Were you planning a new one problem multiple languages? Yeah, there is a couple in the pipeline. It's funny because if I really wanted this channel to grow super quickly, I should just make those kinds of videos. Because if you look at, what are my... oh, look, there's my channel. Just go there. If you look at my popular videos, they're basically all these one problem and languages. And compared to some of the other videos, although I will say, this BQN versus WeWa video has been an outlier in terms of how popular it's been. Usually when I make these types of videos on esoteric stuff, much fewer people are interested. But it's close to 50,000 views now. Anyways, I do, hopefully, we'll start putting out more regularly. I have thought about doing a release schedule. One video every Monday at 5 p.m. or something. But anyways, back to this. So I also kind of want a thinner version of this, but you know what? So here's what we're going to do. We are going to create a function called def drawbox. And the first thing it's going to come with is width, which is going to be an integer. And it's also going to have a start point at some point, but basically we need an arm equals times 2, and then it's just going to be the f string this arm. Let's blow this up a bit. That's too much. Arm. Ooh, and then we accidentally got rid of what we need. Off by 1. Actually, we should just print this. We should just print this. Yeah, I mean, I could do bi-weekly. I go through phases, though, where I get really excited and then I make 4 videos in 1 week. But maybe it would be better if whenever that happens, I just delay the release of it so that people get used every 2 weeks on Monday. And all right, so we got this now. We want to import box display. And actually, what did I call this? A box? This isn't a box. Why? I've got some kind of scroll lock. What the heck is going on here? Oh, my control key was stuck. I want to rename this to UI.py. Move to UI. Not UI. What do I want to call this? Draw? And then we call this draw. Now we come down here. Print chain type. And then we're going to draw. combinator. What do we call it? Tree? What do we call this? Tree? What is wrong with my control key? To clean my keyboard. Draw single tree. And then we're just going to call this, and we're going to call it with 2. And actually, we can get rid of this. Call this save. Call single tree. And now, ladies and gentlemen, we call Jello. And, ooh, there we go. So let's just manually do this first. Single tree, and then we also need a start, which is going to be int. Shouldn't you be using a T, once again, a T looking box, drawing character in the middle? No, and you'll see why in a sec, because, or actually, yes, you are correct. I am wrong. Let's go back to ChatGPT. Thank you. We want this one. You are absolutely correct. Now we come back here. Right, we have a start, so we're just going to guess that that is 9, and we want 1. And then we want another one, which we're just going to guess is 11, and we're going to go 2. We're going to come back here. And I didn't actually even add anything to this. So we need time start. And actually, let's just put that in the string. Woohoo! And why are they both? Right, I didn't actually use the width. And technically, we need a print here. And so what does that look like? It's 1, 2, 3, 4, 5. So let's add 5. And then also we want, I mean, let's go get all our combinators from it's what we will need for the moment. I guess, yeah, we don't really need W. But this is going to be S. So this times 15. And then something like 18. And actually, this should be 0. This should be 1. S is actually correct. We need this to be 15. And Whoa. Did I not change it to 1? I mean, this is going to be a cross. Interesting, interesting, interesting. So fmod's a thing, right? Fmod. No? Import math? Math dot fmod. Return f. Oh, right, yeah. 1.5. Actually, there's an easier way to do this. I'm trying to be too tricky about this. Yeah, we're doing some cool stuff. We're doing some cool stuff. So what we want to do, if width minus 2 equals 0, else larm, this is going to be a little bit ugly. Or maybe we'll go arm like this. larm equals arm plus 1. And then this is going to be larm and rarm. And it's actually 3, isn't it? And so now what I really want is I want this to be 3, and I want this to be 6. Whoops. I mean, we got way too much stuff going on here. We got to clean this up. Huh. Oh. Yeah, first things first, we're going to do this in Python, though. Oh, right. I totally got that wrong. This should be 4. All right, this is perfect. Minus that this needs to be 17. What do you think? Should this Should it be skewed to the left or skewed to the right? Yeah, it's unclear. It doesn't really matter. Always over-indexing on stuff that does not matter. Yes. I mean, the question is, too, is do we actually just want to prefix? I mean, it looks good enough for now. I really do need to order food. Should I take a break? Yes, we're gonna come back to this in a sec. Entertain yourself while I order some food. Question is, what do I want? I mean, sushi would probably be the easiest thing to eat while I do this. Sushi it is then. All right, looks like my food is on the way. Food's on the way. All right, I have 0 suggestions from people about what to play. Zigzag. ING. Glazing. Whoo! Oh, wait, I already used the... Zick? Zach? Caking? Casing? Caking's pretty good, but my guess is that there is a Z word out there that's better. don't know. Caking it is. Nick and zing. Now I have azine. It's up there. Ooh. Well, we'll come back to this later, because I'm too excited about this right now. All right, so in the chat, Matan, if I'm pronouncing that correctly, says you can avoid the if statement in the tree maker by making ram. Sure, let's do a little refactoring here. Well, I mean, the first thing we should do is n. We just should replace this number of arms required. This becomes n. This becomes n, and so does this. And then you're saying by making r yeah, I think I see what you're saying. So if you go larm equals this, and then actually, we just do this. What the heck? larm except larm is the one. That is much cleaner. Except somehow I messed that up now. All right. Even nicer. There we go. So now we just need to build up the logic. To print this out correctly. So let's do that. Define combinator tree. We're going to have a chain, which is just going to be a list of ints. I don't actually know if that's how you're supposed to do that. And I think that's it. This is going to be recursive. So if combinator tree, so you know, interesting. Not sure what I'm doing that is preventing it from... Oh, maybe it's the Unicode? Although I thought all of Python 3 has support for Unicode. And we also probably need a start, which... And actually, we should call this indent, not start. Same with up here. Oh, typing stuff. Might not have been mine, actually, because I don't... Yeah, the str pipe none was added by, I believe, Evan, a.k.a. Sage insert something. Sherlock Sage. So if combinator, if chain, is there an empty method? Yeah, there's not. So if and chain equals 0, return. Otherwise, here we go. So we're basically just now going to encode these last two columns. So we'll start with, you know, s5 w. So actually, let's do we're also going to need a single we need to go back here and we need to get this guy. And we need to come back here to draw. And if width equals 1, print as I was going to say, we should focus on right now. If we do plus 10, we should print that. That's the easiest. That's just going to be a line down to W. Yeah, thanks for tuning in. You'll be able to catch the rest of this if you want on recording. And yeah, the prompt auto completion, pretty cool. Let's come back here though. So if length of chain equals 1, and it's the initial call. Single tree, and we want, actually that's, yeah, I mean, if people think it's cool, they might start doing some stuff, but it's more just for I wanted to learn this, so if other people benefit, that is fantastic. And actually, this needs to go in, actually, we can leave it here. But this just needs to be indent, and then we want to go chain dot pop, and then we want to go, I mean, actually, we can just return this as well. We don't need to recursively call. How many hours has it been? 6.5. It's all right. I ordered food though. And actually, we need to know the arity. So in the case that it's a unary function, it's just function application. So we're just gonna call it f then. And I guess, yeah, this single tree also requires a name, which should really be like the first thing. And then it should be it should be this times indent plus n integer division, then with name. So we come back here. This is now S, we can get rid of that. This is now sigma. And we are off to the races. So actually first let's just try that. +1. +1? No, it should be yeah, easier if we do this as larm, rarm, yeah. I might change that later. Kind of don't like it a little bit. Ooh, and it's going to get complicated. Actually, it won't because we're doing it recursively. All right, so now we haven't called this yet, but this, so if chain at 0, actually, so what is combinator? So it's going to be f at chain equals 1, else it is w. F is for function application. So then we do this, and width. Width is 1. So if we draw combinator tree of 1, and what are the parameters again? Indent is jaw dot nope initial indent and true. Single tree, huh? Singe tree. Whoops. And we also need this. So this is going to be and actually, we can just pass the chain type in directly. Beautiful. And we just need this again, but instead it is the name. This, once again, we can clean this function up, but we'll do it in the future. So this is W. If I switch this to H, or what is it? Half? Ooh, why is it still W? Wait. Yeah, let's just print the chain out. Actually, what does it say? This is a one monadic chain. So it definitely shouldn't be W. If chain equals 1. Oh. Oh. This is a string. I mean, that's a bit hacky, but let's just make it a string then. Look at that. All right. So we've got function application. So yeah, let's go back to our README and update this. So this is, in this case, it's F. You know, F equals function application. And this is also just F, I believe. So now, what happens when we go let's go for a 2-1 chain. It displays nothing at the moment, which is, I guess, what we expect. So if So this is S and phi that we're going for right now. And so it's, no, not what I wanted. So yeah. If initial call, else this. Then I think also width equals 3 if initial call, else 4. And indent's going to be indent. And then we want to go chain dot pop. Can I pop 2? Whatever, we'll do it the hacky way. And then we want to go chain dot. Ooh, we should be popping pop front though. Also, let's go check my. Oh man, my sushi's 37 minutes away. I'm gonna die. Let's just go ask ChatGPT how to pop 1 or 2 elements from front of Python list. Pop 0. Oh, that's true. That's true. We can also just do chain equals chain like that. Yeah, it's probably just the best. Actually, we don't even need to assign it. Just on the recursive combinator call, we just pass it in like that. And yeah, that'll create a copy. Indent will be it's going to be indent plus that, I think. And always is going to be false in here. And actually it's this plus all right, let's take that for a spin. Oh yeah. Now we gotta change this. We gotta change this. The problem is that I'm passing in the actual yeah, we got changes. And also, can we just go ask ChatGPT? is there a way to print a list of integers hyphen separated using f strings? There's not. So then we can pass chain in here. And now we can go back to comparing this with 1. Oh boy, oh boy. That's so sick. Look at that. So now we've got W, we've got S, and if we turn this to a unary function, we've got function application. Oh my God. So now, if we do plus half plus, yeah, it doesn't handle this now. So that's because we just need to replicate this logic, except we know that in this case, it's always going to be a subsequent call. Subsequent. What was I calling it? Initial and succeeding. Subsequent was the word that I wanted. Subsequent. And then this is going to be sigma. Although we actually might need to change this a little bit, but and this is going to be always going to be 4. This is going to be wrong though for a little bit. Oh my God. Look at that. This is that's the wrong bubbly. Wow. I mean, this is wow. This is actually pretty. What an emotional roller coaster we've been on, folks. Because you can see that a 2-1 is an S combinator. This 2-1 is going to form a unary function. That's what the S combinator does. And so then we end up with 1-2, which is the sigma combinator, which makes complete sense because the sigma combinator is the analog of the S combinator. It just flips the argument. Is it the left or the right argument that you're applying your unary function to? And in the next case that we're going to handle, which currently we don't have handled, but what this is going to be is it's actually, and this needs to be parsed first. So this 2, 1 chain is going to form an S combinator. That's going to form a unary function. And then that's going to be 1, 2, 1, which is the phi combinator. Which actually, that's actually not what's happening. Actually, it will, I think it will aggressively call 1, 2. So yeah, 2, 1 becomes 10 plus 10 divided by 2, which is 5. So 10 plus 5 is 15. Then you have 15 on the right. Or is it on the left? Right, because it's just plus. Sorry, I'm getting confused. There's no second half here. So it's just 15 plus 10, which is sigma. And in the final case, it's 2, 1, which is 15. And then phi. Yeah. Yep. Okay. So actually we have to check line of chain is greater than 2. And now we check can this be, it always has to be a subsequent call once again. So now we want the first 3, we want the pattern to be 1, 2, 1. This is going to be phi again? I don't actually know. Wait, let's where did our where did this guy go? Well, let's just see what happens. Actually, this should just be So we've got W. We've got F. We've got sigma, or S and sigma. So now let's guess. If we add another half, yeah, it's not in my, I should go add it right now, to be honest. It's been on my list of things to do for a very long time. Where is it? Combinatory logic. So sigma is basically exactly like S, but instead of AC paren BC paren, it's A paren BC N paren C. So they're basically like siblings, which is why it's called I call it sigma. So basically, like if you are, you know, the pattern, if your binary function is F, that is, this is S, and sigma is F of G of X, like this. Yeah, hopefully that makes sense. Oh man, I'm starving. My food is 14 minutes away. All right, so we've added a half. So this is going to make this a 2-1-2-1-1 chain. It's going to parse the same up front. It's going to be an S followed by a phi. Although what did we yeah, phi forms a 1, except we actually want to get rid of 3 here. And then a 1-1, what's a 1-1? I don't actually know. Well, I mean, let's just evaluate it, see what happens. So it's 10. So I think this last one, it's just F. Although, does it make sense? Where's actually, it's B. Yeah, so this is wrong. A unary function on a subsequent call is the B combinator. So like, and this comes back to this, right? If you know, you're trying to match, right? This is a 2-1 chain, a 2-0 chain, a 0-2 chain, and a 2 chain. So if your chain is a 1-1 chain, that's just B. Yeah. Okay, so this is right now, and we just want to add another one of these. And I mean, can you have an initial 1-1 train? I think so, but I don't think it actually makes a difference. But I might need actually that initial so now, if that worked, ooh, shouldn't have been B though. What happened to phi? Oh, that's what happened. Ooh, except we're off by 1. And also, too, let's just check. So if we have half, half, 10, this should be a 1-1 chain, and it should just be B. So that's exactly correct. Look at this. Look at the power of recursion, folks. Oh, look at that. My sushi is now 16 minutes away. This is incredible, though. This is incredible. This looks like... Let's take this, though. What's going on here? What's going on here? Okay, that's still fine. But my indentation got messed up somehow. So B... Oh, yeah. The offsets stack. I mean, honestly, because we're off by 1, actually. That just kind of... Oh, yeah, good point, sorry. Someone in the chat just asked if I could commit my latest changes. So remove tree diagram. Yeah, we can get rid of all of this. Git add Jello and draw. Let's do a little rough check. Found commented out code in jello.py. Well, no, that's fine. So, to be honest, this actually isn't anywhere near as complicated as it would seem. Like, basically, there's just a set of patterns. 2-1 is S. 1-2-1 is phi, aka fork, and this is hook. 1-2 is sigma. 1-1 is B. And the rules is basically, I think 2-1 takes the highest priority. And then after that, 1-2-1 and then 1, 2. And then basically every single time you consume the number of quote-unquote functions, so for s you consume 2, you just pop those off the front of the list and then append whatever the arity of that formed function is. So here you pop off the 2, 1, and then you replace it with a 1. And then you go and parse 1, 2, 1. That's the phi. You pop off all 3 of those, and then replace that with a 1 because the phi is also a unary function. And then when you have 1, 1, that's just the B combinator, and so that's all this is. Yeah. And so, for instance, if we added another half, or actually, so like, do we have square? I assume square is here. Yeah. So if we do square, this is going to become 100, and then there's just going to be another B combinator underneath. Yeah. C. Caffey saying, I already have problem parsing. Yeah, I mean, it's still not trivial. And then so, you know, the unary is going to put... I mean, I guess the thing is... we still do need to... We got to fix this a little bit. All right, I got to check... Oh my god, my food is still 14 minutes away. Let's see if we can fix this. So actually, let's just reverse. I now want the right arm. I think it's this times 2, right? Why is S? S is 3. Three divided by 2 is 1 times 2. Right. Okay, I mean, we got this much right. But I think which should be 5 actually. This is for B. Yeah, that worked. And my guess is this also. Why is 5 4? So yeah, what if so this is a 1, this is a 2 1 2 1. So yeah, what if we do this? That's wrong then. So actually, is it subsequent calls or is it followed by an even or odd? I think that's what it is. Well, let's just ooh, what happened? Oh, right, I didn't give it a number. Oops. Pretty dope. Where's my print screen? Let's try that again. Let's try that again. There we go. Let's go here. And now I mean, it's not perfect, but we'll fix it at some point. How do I get rid of... Yeah. I mean, maybe let's do that. Let's take a small... I mean, my sushi has been eternally delayed. I'm just gonna starve. Maybe what we should do though is we should go update the combinatorial logic website. It'll only take a couple minutes. Table. The reason, I guess maybe one of the reasons I haven't actually done this is like, where do I put, if we go to the combinatorial logic website, like where do we put sigma? The idea is that, you know, it kind of increases, you know, we put the B's together and the more complex they are, you know, the more letters there are after the dot. But S is at the top because S and K are the two fundamental combinators. But like I want sigma to be next to S because they're siblings. But I guess we'll just put it after Picard, you know, whatever. Why not right after S? Yeah, because that's the thing is I just mentioned that S and K are at the top because they're the two necessary ones to spell all the other ones. And like typically you hear about the SKI or the SK combinatory calculus. But you know, whatever. Better to have it there than like just not have it there at all. Let's go get sigma. And there is no bird for this. What did I call it though? There's somewhere on GitHub/code report/ meeting notes. Hyphen notes. Not this one. I called it the Violet Starling. Sure. Why not? Why? Because it's a sibling. We gotta, you know. And this is irritating. How do we spell this? Ooh. You know, to do. Or we'll just put a question mark. We don't need that right now. Actually, it doesn't have one. Wow. Haskell does not have one. APL also does not have one. BQN though. BQN does. And it is before. So do we got BQN still open? Yes. This guy right here. Monadic before. Which is beautiful because you can see that up here, this is the, I guess, yeah, it's obvious that it should go here in hindsight now. I don't actually know. This wasn't introduced in any book. So that's the first one. Where's my sushi at? Sushi still, it's just not coming. And then delta. Delta is going to go right below this. That is delta. Now we need delta course Greek. I need this one here. What did I call him? What did I call? I called this one, yeah, the zebra dove. Clearly just looking for birds that are, you know, of the family. So this one's the zebra dove. Very nice. Once again, I don't really know this. We'll add this later. I mean, honestly, yeah, someone's saying I respect the HTML. I don't. I hate it. And honestly, this website doesn't even work on mobile, so it's pretty garbage. And I think I literally have on the GitHub repo saying to completely revamp it, but I don't have time. It works for some definition of the word, works on some platforms. And once again, the delta is the analog of the D combinator, and the D and delta are just the dyadic versions of before and after in BQN. So we go save without formatting, and get status, get diff. Yeah, it looks close enough. Get add table. Whoops. Add. Delta and sigma to table. Does equal less count as sigma? Let me push this and then stack GHCI. Do I need to import a library to get access to that? What is it? Equal. And the type of I'm not enough of a Haskell expert to know for sure, but this, no, does not look right. What sigma would be is if this FA and F paren A arrow B were swapped. So technically, like my favorite, how do you do this? We want to build up plus is our binary function, and then we're gonna just have times 2. So 2 times. So if we give this 10, this should be tripling your number, right? Yeah. A way to like spell this is if you flip the, is that right? Actually, no. You don't flip app. You don't flip applicative. You flip your binary function. It needs to be in parentheses still. So this technically, I mean, because your binary function here is associative, or no, commutative, both sigma and s will give you the exact same result. But if you are commuting the binary operation, so if we go back to when we were spelling these, right? It's x, g of x versus f of g of x with x. If f here is associative, doing this doesn't matter, right? Because the operation is commutative. It doesn't matter the order that you pass your arguments. But imagine if you had a flip function in Python, and if you called, this function s, and then I guess, if f takes f and g, you can simulate sigma by flipping f. If that explanation makes any sense at all. All right, I'm gonna take a quick break here. I'll be back in a sec. Maybe my sushi might be here, in which I'll be gone for a little bit longer. But yeah, we will put the Scrabble back up if people want to play this. Yeah, we'll do this for the moment. I'll be back. All right, folks, the sushi's here. I'll be back. I gotta go downstairs. It takes like 10 minutes because elevator takes a long time. Bye. Oh, wait. Mic's back on. I don't know who's still here. But nobody has suggested. Why is Oh, there we go. Nobody suggested any Scrabble words. But we're gonna play a little Scrabble here while I eat my sushi. How much am I down by? Oh, I'm winning by 30 points. There we go. Don't mind all the... Oh my god, this green dragon roll. Look at that. Woo! Avocado, protein, carbs, and chopsticks. Fantastic, folks. Where are we at? 8 hours? Almost 8 hours? Should we go for 10 hours? I think we should go for 10 hours. Thanks for tuning in, C4 Tubo. Oh my god, I'm starving. So as I'm... Gotta turn this back on. Put this over here. Oh my god, sushi's never tasted so good. Hmm. 14 points doesn't make the cut. Viz is a word, V-I-Z. I don't know where you'd put that, though. Zin is also a word. Z-I-A. It's not a word. I mean, biz is a word, but that's not going to make the cut. Zare is a word. I don't have an R, though. We're just going to do as on. Only up by 5 points. And there's still one blank left. Zero. Ooh. Second top word. Desire? It's not a word. Should we just do zero? I mean, it's a pretty bad word, to be honest. Leaves you with two I's, a V and a Y. Vizier. Oh my god, that would have been so much better. Zori also would have been way better. Oh no. Is that a bingo? No, it's not. But now I'm down by 14 points. Jervy. 48? What is that? Is that your local time? Almost 1 a.m.? It's not good. 8th highest scoring word is 15 points. And almost definitely it's got the blank, which is not good. I say we go for vid. There's a chance we could get the blank. Except we did not. You're nervy, petty. Oh yeah. Down by, what is that, 37? Not looking good. 35 points. There we go. There's the top play. Tied at 382 now. Luckily, the computer does not know that there's an advantage to finishing all your tiles, but I don't think it's going to make a difference. This Tiri might tiara. GG, lost by 12. All right. Did this get updated? It did. We've now got sigma and delta. So now the question is what do we want to do now that I've had something to eat? Well, first of all, actually, let's just let's type our examples in. I turned that on, right? So that's our first example. And we're going to wrap this up in T-minus 3 minutes because I got to go now. So I guess we'll just check that these in the monadic cases work. So then we have plus square times. And what did I say here? Monadically, this forms, S forms a monadic function that is then used in sigma. That's exactly what happens here. And then last but not least is plus times div and then half. And yeah, this one doesn't work yet. But still, pretty good. All right, folks. It has been a pleasure. Maybe I'll do another one of these live streams tomorrow. If not, I'll do one in the next couple weeks because we still got a lot of work to do. Yeah, we gotta fix this stuff up. Git add rough, and we gotta commit this. There's no sparkles here. This is recycle. And we're gonna call this small draw changes. Ooh. Pull. Git config pull dot rebase false. We're good to go. Now we push. And you can see that all of this basically is in the README. Yeah, great start. I understand at least the monadic chains quite well. And I think I have a good understanding of the dyadic chains as well. Multi-chains we have not gotten to. And also parsing the leading constant chains, etc., etc. We'll get to all that. But honestly, pretty fantastic. This is basically how I envision this going, to be honest. I wanted, keywords to be translated into atoms. The trace I hadn't visualized at the time. But then this kind of printing out the type of chain and translating it into the combinators is exactly the way I thought this was going to go. I lost hope at about around the 4-hour mark. But then around the 5-6 hour mark, nailed it. Anyways, I will leave this once again as a link both in the chat and in the description. Thanks for watching. Hope you have a great day, and we'll see you in the next one.